So, okay. So now we are live. We will wait for 2-3 minutes to join others. Let them join first. Meanwhile, many have sent messages like good morning to all. Biswajit Debnath, good morning. Good morning, sir. Let them join, and hopefully within 1 minute we will be able to start the session. So we are getting good response. Within a minute, many have joined. Still, as we are lots of participants, so we must wait for them due to as this year we are in the era of technology, there may be some errors. So let them join first, then we will start. Good morning all. Yes, we are going to start. Arnob Nath, Mousomi Raut, thank you. So with the permission of chair, should we start, sir?
Oh, yes, go ahead, please.
Okay. So a very good morning to all of you. I am Dr. Ankan Sinha, welcoming you all in the International E-Conference on Advancement of Research in Physics and Teaching Technique during Pandemic Period. So we are very happy that we are able to organize such kind of event. This event is organized by the Department of Physics, Government Degree College, Dharmanagar, North Tripura, in collaboration with Department of Physics, Women's College, Agartala, Iswar Chandra Vidyasagar College, Belonia, and Ramakrishna Mahavidyalaya, Kailashahar. So at the same time, we are very fortunate that around 500 participants are participating in this mega event from different corners of India as well as from abroad, like Sri Lanka, Bangladesh, and many other countries also. So we are very lucky. Okay, yes, sir, we are able to hear you, sir. Okay. The theme of this e-conference is need of the hour. I would say that we must continue our mind to be ignited towards research work and teaching techniques, regardless of this pandemic situation. So I can assure you that this program is going to be the best part of your everyone's life. Why? Because it contains the innovation, the updates, the knowledge, the informations in the field of physics and in the field of teaching techniques also. So we are going to witness this, and we are with us today. We have with us in the form of Chief Patron, Professor Arunodoy Sahasar, former Vice Chancellor, Tripura University, and Chairman, State Council for Higher Education, Government of Tripura. We also have with us the patron of this mega event, Sri N.C. Sharma Sir, Director, Education of Higher Education, Directorate of Higher Education, Government of Tripura. We have with us the President of this program, Sri Gautam Das Sir, Principal in Charge, Government Degree College, Dharmanagar, North Tripura. On the dais, we have with us convener of this program, Dr. Raghunandan Das Sir, Assistant Professor, Department of Physics, Government Degree College, Dharmanagar, North Tripura. As a coordinator of this program, we have with us Dr. Rahul Bhattacharjee Sir, Associate Professor, Department of Physics, Iswar Chandra Vidyasagar College, Belonia. So, and with hope to continue this event, I would like to request Dr. Raghunandan Das Sir, the convener of this program, this mega event, the well-renowned speaker as well as the stalwart of physics. So do come and deliver his welcome speech. So please, sir.
Thank you, sir. Thank you. Thank you very much for highlighting the conference aim and objective. So we are grateful to you also. A very good morning to all, ladies and gentlemen. Let me start with Albert Einstein observation. Look deep into nature, and then you will understand everything better. Or I do not need to know everything. I just need to know where to find it. Honorable Professor Arunodoy Shaha, former Vice Chancellor, Tripura University and Chairman, State Council for Higher Education, Govt of Tripura, as well as Chief Patron of today's International Tea Conference 2021. Respected Director of Higher Education, Govt of Tripura, Sri N.C. Sharma sir, and Patron of the international event. Respected President, Sri Gautam Das, Principal in Charge, Govt Degree College, Dharmanagar. Distinguished scientists, academicians, colleagues, participating faculty members across the nation and abroad, research scholars, and my dear students from various UG and PG courses. It is a matter of great pleasure that Department of Physics Government Degree College Dharmanagar, in collaboration with Department of Physics Women's College Agartala, Ishwar Chandra Vidyasagar College Belonia, and Ramakrishna Mahavidyalaya, Kailashahar are organizing 2 days international e-conference on advancement of research in physics and teaching techniques during pandemic period. Let me spare a very few words about the organizing colleges and department. All the organizing colleges are Govt institutions and enjoying affiliation to Tripura University, a central university. All the institutions are pioneering institutions in the region and scattering and fostering higher education among the young minds. All four physics departments of four colleges are offering general and honors courses curriculum framed by the Tripura University. We are happy to share you that we have been organizing seminar, workshops, webinar, conferences in regular intervals, particularly in the pandemic period. In the last couple of years, we organized such events in number of times, either jointly or individually. As convener of this international event, I welcome renowned educationist Professor Arunodoy Shaha, sir, former Vice Chancellor, Tripura University, and Chairman, State Council for Higher Education, Govt of Tripura, and Chief Patron of this international event, and Patron Sri N.C. Sharma sir, Director of Higher Education, Govt of Tripura, Agartala. In this 2 days conference, six distinguished educationists in diverse field of research in science and technology will deliver their valuable talks. I welcome all the invited speakers in this conference and expressing my thanks and gratitude to all of them. Friends, during the pandemic period, teaching learning process was badly hampered. Physical classes are stopped. Both students and teachers are compelled to stay home. To motivate the students community and to give glimpse of research activities, we have been organizing such type of events regularly, and this one is the bigger platform also towards the same goal. And each time we are receiving inspirational fuel from the overwhelming response from the participants to do something better. This virtual platform is providing an opportunity for all of us, teachers, distinguished research persons, researchers, students, community. I do hope and believe this particular international conference also be helpful for the knowledge thirsting people in general and the student fraternity in particular. In this context, it is very much relevant to organize such a program. It is a program for students, researchers, faculty members, and all the knowledge thirsting peoples. Around 500 participants across different parts of our nation as well as abroad registered in the international event. I, on behalf of entire organizing committee, welcome you all, hoping your active participation will make every session fruitful and we get inspirational fuel to organize such event further in bigger platform. In this today's International Lead Conference, we have two technical sessions. In each technical sessions, we have three renowned educationists in their respective fields, invited speakers from our neighboring countries as well as from different renowned institutions of our country. We, are, we have among with us pioneer researcher and academician like Dr. Monira Jannatul Kubra, Associate Professor, Department of Physics, University of Rajshahi, Bangladesh. Dr. Jafri, Senior Lecturer in Physics, Faculty of Applied Sciences, Southeastern University, Sri Lanka. Sri Shantanu Purohit, Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. Dr. Subhrotanu Bhattacharjee, Associate Professor, Department of Physics, Kalyani University, West Bengal. Dr. Nirmal Kumar Sarkar, Associate Professor, Department of Physics, Karimganj College, Karimganj, Assam. Dr. Bijon Deb, Assistant Professor, Ramakrishna Mahavidyalaya, Kailashahar, Tripura. A hearty welcome to all of you, sir. I do believe during these 2 days conference, we can provide a platform through which participants, particularly students, can sharpen their knowledge, update themselves. I request all the participants to participate actively, listen each and every talk, interact with the resource persons, and enrich yourself. Online feedback form will be shared in the chat box only during the every end part of the technical sessions. Every registered participants need to submit all the feedback get certificate. I must express my thanks and gratitude to Sri Gautam Das sir, Principal in Church, Government Degree College, Dharmanagar, and President of this international e-conference for his constant support, inspiration, and encouragement. I am expressing my thanks and gratitude to the advisory committee members, Madam Srimati Monika Verma, Principal, Women's College, Agartala, Dr. Bimolendu Ghosh, Principal in Charge, ICVC Belonia, Dr. Pinaki Pal, Principal in Charge, RKM Kailashahar, for their constant support, encouragement, and valuable advice. I am expressing my thanks and gratitude to all the coordinators, Dr. Rahul Bhattacharjee, Associate Professor, Department of Physics, ICVC Belonia, Dr. Subrato Dev, Assistant Professor, Department of Physics, Women's College, Agartala, Dr. Bijon Deb, Assistant Professor, Department of Physics, R.K. Mahavidyalaya, Kailashahar, Dr. Sujit Ranjan Das, Assistant Professor, Department of Physics, Government Degree College, Dharmanagar, for their constant support, cooperation in all respect. I must express my deep regards to Dr. Ankan Shinasar, Secretary, Teachers Council, Government Degree College, Dharmanagar, for his constant support in all respect. I am thankful to Srimati Mithu Das, Technical Coordinator, Assistant Professor, Department of IT, Government Degree College, Dharmanagar, for her constant support. I am expressing my deep regard to all the members of organizing committee for their extended support. Last but not the least, I am expressing my deep regard to all the officials, everyone, for lending their support and cooperation. I welcome one and all once again and wishing a grand success of the grand event. Thank you all. Officer, please.
Now, I would like to request our chief patron of this program, Professor Arunodaya Sahasar, for delivering his speech and share his experience with us, sir. So please, sir.
Thanks, Dr. Ankun Sinha. At the outset, I like to congratulate Govt Degree College, Dharmanagar, for organizing International E-Conference on Advancement of Research in Physics and Teaching Techniques during pandemic period. Today we are all together. This program is the international one because we are joined by the renowned physicists across the world. I have gone through the list, from Bangladesh, from Sri Lanka, from other countries also, and from within our state and India. So it's a really, in true sense of the term, it is international. Once again, I like to congratulate the faculty, the students, all the stakeholders of Govt Degree College, Dharmanagar, for organizing this international e-conference. And I hope they in near future also keep on organizing this kind of program. And for them, I put my advance thanks to them. And with this, I like to start. And here there is one inaugural program, and that has already been set by the speaker. With us, President Principal Gautam Das, Dharmanagar Degree College. With us, the patron, Sri N.C. Sharma, Director, Higher Education, Government of Tripura. And present with us are Dr. Raghunandan Das, convener, and Dr. Rahul Bhattacharjee, co-convener or co-coordinator, I must say. It is written ARPTTPP. I think it is the abbreviation of Advancement of Research in Physics and Teaching Technique during Pandemic Period. Yes, they are all there with the support and cooperation of all of them. I am sure the e-conference is going to be a successful one. Actually, the topic they have decided to deliberate is the, research in physics, teaching the methodology to be adopted during the pandemic period. Basically, actually, I am reminded of my old days when I was a kid going to the schools. At that point of time, we were asked to write an essay, whether science is blessings or curse. In Bengali, I remember. So we used to put all the points in favor of blessings and the points against curse. It is a mixed kind of reaction. Science is a blessings because, due to science, this invention and discoveries, we achieved a lot and we, discovered many things, and life and civilization is different one. We are advanced one. But at the same time, science is also curse. Why? Because with this scientific advancement, atom bombs were evolved and dropped, and civilization was at that point of time in danger. So it is a mixed kind of thing. Science is a blessing as well as curse. Now, I may ask one more question to myself, whether pandemic situation which now we are passing through, is this a blessing or curse? It is obviously curse because, we are confined, self-exiled confinement. We cannot go out every day. There is protocol to be maintained. The curfew, Corona curfew is there. Restrictions are imposed. So, life is stopped. in a sense. So it is not a normal life we are leading in this period of pandemic situation. So it is a curse. And not only that, every day we see the positivity is this, the mortality is this. So we are under a lot of threat. So it is not good one. So it is a curse. Maybe man-made, maybe not man-made, but it is not good one. But I must say, I must beg your pardon if I say pandemic situation, the period is also a blessing. Why blessing? Yes, the example we are now setting is set by Dharmanagar College. It's a blessing because it is very difficult to organize one international seminar in during normal period. How come? Because the speakers are very renowned ones. They stay outside the country. But this pandemic situation forced us to arrange one e-conference where boundaries are, thrown away. We have, all are together. So during pandemic situation period only, we are able to arrange an e-conference and which is international in two sense of the term. So pandemic period is a blessing and as well as a curse. But one thing I must say that if it is not welcome, it is a curse, we must find out some way how to eradicate and come back to our normal way of life. That is today's exploration. It is due to science, particularly physics. Our world has become a village. That is why it is possible to organize one international conference sitting in Dharmanagar. So, and not only that, the conference is cost effective. There is no cost at all. If we could arrange one international conference, inviting people to come, arrangement, their hospitality, it would cost a huge amount of money and resource. But since it is a different kind of virtual kind of meeting, so it is cost effective, no cost at all. It saves time, it saves energy. So that way, pandemic period, shows us how the disadvantages are converted into advantages. So it is a blessings in disguise. But one thing I like to highlight is this. Nowadays, we developed a lot. We are very, very advanced in science and technology. And that is due to the contribution by the scientist, by the researcher in the field of physics. Whatever technology we mostly see, we mostly use in our day-to-day life is the outcome of the contributions by our researcher, by our university and college professors. So you see, yes, due to pandemic period, now restriction of movements there is a restriction in the movement, but we are not barred of disseminating our knowledge. We could use the technology, online research, online class taking, and this is a situation where we are able to overcome the disadvantages put by corona and this pandemic situation. So physics is behind us. Of these opportunities and get rid of the disadvantages. So I like to thank physics. I like to thank the researchers, the scientists, working in the domain of physics. And physics is the hardcore, very in many subjects. They are also contributing in their own way, but in concrete contribution is being made by the domain which is dominated by physics. So in our colleges, in Dharmanagar College and other colleges, a lot of bright young researchers are there. They are publishing, contributing their articles. very substantial article. I know they are publishing their articles in the world refereed journals. So once again, I like to encourage, thanks those teachers, faculty members in the colleges of across Tripura. Uh, I like to congratulate them because, in spite of their limitations imposed by the protocol of Corona, they are not, stopped, deterred. They continue to, develop a different kind of technology, teaching technology, so that the deliverance of education is not stopped. Once again, I like to talk about, say, there are two kinds of calamities. One is natural, one is unnatural. Come whatever, natural or unnatural, we are able to, overcome, finally, with the help of our innovative skill and efforts. Physics, particularly, shows the light at the end of the tunnel. In fact, we are passing through a dark tunnel, but we are hopeful, we are sure, with the different kind of advancement in the subject of physics, we will be able to sure to cross the tunnel, and we will reach the light at the end of the tunnel. Finally, I like to just mention a different. It is not only so long I was talking about research, but in teaching technology, pedagogy, what I mean to say, they have undergone a lot of change. Earlier, we used to go to the class and the teacher student directly interacting in the classroom. Now that is, for the time being, not possible. But through online and offline, as you know, there is a controversy that we are able to communicate to the students. And students are also very smart nowadays. They, through Android, mobile, and all that, they can reach, they can study, keep on studying. Most of the colleges right now, the classes are held through online. Exams are, taken through online. And these are the different type of methodology now we are following, which we could not think about earlier. Once long back there was Gurukul. Our students used to go to Guru, leaving behind their home, and then time came just going to the schools and institutions and carry our studies. Now it is different. Under this pandemic situation, we sit at home. I mean, students can sit at home and have access to the teaching, learning, and reading, everything. So, and these are due to the contribution, technological advancement through physics only. So separately, I like, it is a not only physics, there is other kind of contributions from other areas also, domain also. But I must congratulate the scientists, the researchers, the teachers, faculty belonging to the Department of Physics, domain of physics, who are enormously contributing to this advancement of knowledge. So once again, I like to thank all of them. And finally, I like to come to the conclusion. Actually, we people are man, different kind of animal. They can adapt in any situation. Many creatures are not able to survive, but we are so, what should I say, capable, with the help of our knowledge accumulated in the past, through the past. We are able to overcome all kind of obstacles, limitations, and that is the time we are passing through. And once again, the topic they have selected is very relevant. Advancement of research in physics and teaching techniques. Yes, these are two very much related, the two sides of the same coin, research and teaching. I am congratulating Dharmanagar College for choosing this kind of topic, which is very, very relevant in this time period of pandemic situation. I have given a lot of, lecture, big lecture, but I like to conclude again with extending my thanks to the college of Dharmanagar Degree College for arranging this kind of program, inviting researcher professors from within the state, within the country of India, and outside India. It's a beautiful, excellent arrangement they are doing. Earlier also, I remember Dharmanagar College keep on doing these kind of beautiful academic exercises, and they are ahead of other many colleges of Tripura. I must say, other colleges are also trying, but Dharmanagar College is ahead of other colleges in terms of this holding this kind of seminar, symposium, conferences. There are other colleges. There is one particular college. They are also doing excellent job. Other colleges are coming up. We encourage these kind of research and activities. Whatever support, yes, we are ready to extend. Before concluding, I like to once again extend my thanks to Principal Gautam Das and his competent colleagues and other around him for making this program successful. Particularly, I like to thank Sri N.C. Sharma, Director Higher Education, who is with us and who is always extending support to this kind of academic activities. And yes, we look forward to Sri Sharma for helping, for extending support to all the colleges for arranging this kind of e-conference or whatever conference seminar. Yes, now we have this with us, Sri N.C. Sharma. He is, always with us. Anyway, once again, before I conclude, I extend my wholehearted thanks and gratitude to you, and I feel myself honored for being with us. You have invited me to be with you. I wish all the success of this international conference. Thank you. Thank you very much.
স্যার মাইকটা মিউট আছে।
আমরা পারবো না, আমাদের
I think he's not able to. Raghu sir, I think he's not able to hear us. Raghu sir.
Thank you, sir. Thank you, sir. Yeah. Thank 1 minute. Huh? Thank you, sir. Thank you for your presentation. You enlighten us. We have come to know so many things. Listening you, we do feel that you are the insider. Always you are encouraging. We are supporting us. For that, we are extending our thanks and gratitude to you, sir. We are thankful to you. We are grateful to you, sir. So now I am honored to invite Sri N.C. Sharma, sir, Director, Department of Higher Education, Govt of Tripura, Agartala, and patron of this event. Our directors are always encouraging, motivating us for organizing such educational programs. He is source of our inspiration. He is kind enough to accept our invitations and sparing time with us in his very busy schedule. Thank you, sir. Over to you, sir.
Thank you, all of you. Uh, I am very much privileged to be here in such a international webinar, and we have got our very respected Professor Kailashahar, former Vice Chancellor Tripura University, and our Chairman, State Council for Higher Education, and I am very much obliged to him that he is guiding us for the betterment of higher education in the state of Tripura. Sir, thank you that you are giving time in all this kind of major events which our colleges are organizing time to time, and they are taking the opportunities of digital platform for connecting world with our colleges, with our students, with our researchers. I must thank Sri Gautam Das, Principal, Dharmanagar College. He is also organizing such kind of webinars and e-conferences almost monthly, twice or thrice, and in all events he inviting me to be present. So he is also connecting all the persons, eminent persons in this field and other fields also, so that the students community and the researchers community get benefited, and we also get benefited from such kind of e-conferences. I must thank Dr. Raghunandan Das, convener of this event, that is International E-Conference on Advancement of Research in Physics Teaching Technique during Pandemic Period. So I also thank Dr. Rahul Bhattacharya, coordinator of this project, and other dignitaries, professors who have joined in this webinar. And I must thank to the researchers, offer my thanks to the researchers and my dear students who have joined here. And I also thank the distinguished persons who have joined here to deliver their presentation on the advancement of physics and the use of physics in this odd time, that means pandemic situation. We all know that we are going through a very hard time, and that is in this prevailing COVID situation. All kind of development works, all kind of developments in different areas have been almost blocked, and we are facing number of hurdles to continue our developmental works, our researches. The education sector is badly hampered. The students are now in whom they have no direct relation with their friends, with their teachers, with their patrons, with their research guides, and like this. So, being a part of the education department, I am also facing a hard time to continue our higher education and expand our higher education so that the students community get benefited. So there are a lot of negative aspects we are facing day to day, but there are some positive aspects also. Professor Shah sir already told that we should find out the positive aspects of this bad time and use this properly for the students community and the research scholars and other persons who are related with the education sector. We have got the we had that is there was digital platform earlier also, but we did not use uh, use at that time in a large manner or large area. But now we are bound to uh, use this digital platform for our communication, and for this reason the digital platform is developing day by day, and we are getting connected with the all areas of our nation and also with outside of our country. So this is a good thing that we have learned in this pandemic time, and we are using this platform for our betterment of our mankind. Friends, I am not expert in physics, but I have some connection with the physics institutes, and from them what I have learned that in this pandemic situation, the experimental research is very hard to carry on the situation. The best we can do is to use computational methods to simulate real life situations, or to make use of the existing simulation softwares. So as you all know that physics is the mother of science, and everywhere there is the scope of physics. You all are experts in physics, so I request all of you to find out the better methods what can be used by others to use the pandemic time as a positive gesture. So I think that theoretical research can be carried out in the increased communication in this time with your supervisor, with your advisors, with your peers, and this can be done by the Google Meet and other platforms what you are using almost daily for international and national communications. So I hope you all researchers and the students in the physics and the professors in the and other dignitaries in the physics, we will work together. We will make this situation uh, useful for us for betterment of the community through the international and national links. So especially I want to communicate with my students, dear students who are working and studying in different colleges and research institutes. You are the people to make the negative as positive. You are the people, you are the fighter to win the COVID situation, and take this opportunity, take this negative aspect as the opportunity for working, for inventions, for discoveries, and which can be utilized by the uh, general people for make their life better in this bad time which we are facing now. So in this words, I will request all, please you go forward. We are with you, and Professor Shah sir already told that we are in our higher education department will be always helping you in all aspects wherever is necessary, and you take this opportunity to go forward and make this world better for living. So with these words, I must thank all. Again, I thank and extend my namaskar to all and myself, Professor Saha. And with these words, I want to conclude. Thank you.
Thank you. Thank you very much, sir. Thank you, sir, for your constant motivation, encouragement, and support. We are really grateful to you. We are receiving all sort of support from you. So once again, we are expressing our thanks and gratitude to you for being with us. Thank you, sir. Now, now I invite Sri Gautam Das sir, Principal in charge and President of the conference, for his presidential speech. Over to you, sir.
Thank you. Good morning to all. Respected Chief Patron of today's International E-Conference, Professor Arunoday Saha, former Vice Chancellor, Tripura University, and presently Chairman of State Council of Higher Education, Tripura. Respected Patron, Sri N.C. Sharma Sir, Director of Higher Education, Government of Tripura. Members of Advisory Committee are Madam Monideepa Debbarma, Principal, Women's College, Agartala; Dr. Bimalendu Ghosh, Principal, Ishwarchandra Vidyasagar College, Belonia; Dr. Pinaki Pal, Principal, Ramakrishna Mahavidyalaya, Kailashahar. Respected Convener, Dr. Raghunandan Das, Assistant Professor, Department of Physics, Government Degree College, Dharmanagar. All coordinators, members of organizing committee, our invited speakers, resource persons, educationists are Dr. Monira Jannatul Kobra, Associate Professor, Department of Physics, University of Rajshahi, Bangladesh; Dr. Nirmal Kumar Sarkar, Associate Professor in Physics, Karimganj College, Assam, India; Dr. M.J.M. Jeffin, Senior Lecturer in Physics, Southeastern University, Sri Lanka; Dr. Shubhrotanu Bhattacharya, Associate Professor of Physics, University of Kalyani, West Bengal, India; Sri Shantanu Purohit, Assistant Professor in Physics, University of Chittagong, Bangladesh; and Dr. Bijon Dev, Assistant Professor in Physics, Ramakrishna Mahavidyalaya, Kailashahar, Tripura, India; and all participants, respected colleagues, and my dear students of UG and PG courses. On behalf of Government Degree College, Dharmanagar, Tripura, India, I welcome you all on today's International E-Conference on Advancement of Research in Physics and Teaching Techniques during Pandemic Periods, which will be held on today and tomorrow, that is 10th and 11th July 2021. It's a great privilege to me and great honor to our college to address you all dignitaries in this occasion. I congratulate all principals and their team of 3 colleges for their cooperation to organize such a e-conference program. Our chief patron, Professor Arunoday Saha sir, mentioned that near future college should organize such program in a maximum number. He mentioned the use of science in school level to PG level and today's thoughts, the blessing of science and bindings of pandemic situation, advantage and disadvantage. Sir also mentioned how to back in normal life, mention teaching pedagogy, digital tools used in e-learning. Our patron director sir mentioned the use of digital platform to connecting world Also mention facing the hurdles in development of education sectors, advice to positive thoughts for students. Also mention experimental research, better method in physics to be used during pandemic situation. Students are the fighter to win the pandemic situation, etc. Thanks to our Chief Patron Sir and Director Sir for their continuous support, encouraging suggestion, their participation instead of their busy schedule. We will try to follow your suggestions in future by heart. Again, thanks both of you, sir. In pandemic period, education has changed dramatically with the distinctive rise of e-learning, whereby teaching is undertaken remotely and on digital platform. Research suggests that online learning has been shown to increase retention of information and take less time, meaning the changes coronavirus have caused might be here to stay. Today, we will listen some of the advancement of physics like advanced functional materials, applied and fiber optics, atomic and molecular experiments, condensed matter physics, elementary particle physics, theory of experiment in magnetics, nano photonics, nanofabrication and analysis, nuclear physics, theory of and experiment optics, physics of complex system and biophysics, plasma physics, quantum physics, high energy physics, etc. in the e-conference, in lecture or presentation mode. I congratulate to all invited speakers, research persons, as they will share their valuable time with us in these international e-conferences. I would like to share the information that Government Degree College Dharmanagar, Tripura in India has performed two international webinar and 20 national webinar within the period of June 2020 to June 2021. I hope these today's technical sessions of the e-conference and the interaction sessions will be very much informative and attractive, as a good number of physicists are available in this conference as resource persons. I wish a grand success of this international conference. Once again, thank you all and good wishes to all participants on behalf of Government Degree College Dharmanagar, Tripura. Wish your good health and safety life in these pandemic periods. Thank you. Thank you. Namaskar.
Thank you. Thank you very much, sir. Thank you for your encouragement, constant support. All times you are supporting us from the front. So we express our thanks and gratitude to you, sir.
Thank you.
Now I am inviting Dr. Rahul Bhattacharjee, Associate Professor, ICVC Belonia, and one of the coordinator of this conference for offering vote of thanks. Over to you, sir.
Thank you, Raghu. Am I audible? Yes. So, good morning, one and all. On behalf of the organizing committee of the International E-Conference on the Advancement of Research in Physics and Teaching Technique during a pandemic period, I myself, Dr. Rahul Bhattacharjee, Associate Professor of Ishwar Chandra Vidyasagar College, Belonia, South Tripura, took the opportunity to propose a vote of thanks to all those persons who are directly and indirectly contributed in the webinar and make it successful. At first, our grateful thanks to Chief Patron, retired Professor Arunodoy Saha, former BC of Tripura University, and the present Chairman of State Council of Higher Education and Research. Sir rightly point out that pandemic period is some way a blessing that we find new way of living and spreading the knowledge. World are now connected in new way. We have to convert all our disadvantage into advantage. Thank you, sir, for your good wishes. We are extremely delighted by your kind presence, sir. We are extremely thankful to our patron, Sri N.C. Sharma, Director, Higher Education, Tripura, of his valuable words in the international webinar. Sir said we are taking help of digital platform to provide a connection between researcher and student for a advancement of physics and research, convert all the negative aspect into a new opportunity. We are very much fortunate that our president of the webinar, Sri Gautam Das, is present here. Sir always encourages to conduct such webinar and help us whenever we approach him for any reason. Thank you, sir, for your guidance and valuable words. We are extremely lucky that our resource person from different regions of the globe extended their hands and ready to deliver lectures. Our special thanks to Dr. Munira Janatul Kobra, Associate Professor, Department of Physics, University of Rajshahi, Bangladesh, Dr. Nirmal Sharkar, Associate Professor, Department of Physics, Karimganj College, Assam. He is also my teacher. Dr. M.M. Jaffin, Senior Lecturer, Department of Physics, Southeastern University, Sri Lanka. Dr. Subrothanu Bhattacharjee, Associate Professor, Department of Physics, University of Kailani, West Bengal, and Shantanu Purohit, Assistant Professor, Department of Physics, University of Chittagong, Bangladesh. We are eagerly waiting to hear your lecture and learn something. Thank you all of your kind response. I would like to convey my personal thing to my two young, dynamic, enthusiastic juniors, Dr. Raghunandan Das, convener of the webinar, and Dr. Sujit Ranjan Das, one of the coordinator of the webinar, for their hard work to make the webinar in its present form. Both of them build the entire team, make a common platforms, and beautifully arrange everything. Also, both of them engage each other, one of the members of the organizing committee, so that all of us deliver our best. Hope we'll work together in future. Thanks to the other committee members of my ex-colleague, Dr. Subroto Dev, coordinator of Women's College, my students, Dr. Bijan Dev, coordinator of Ramkrishna Mahavidyalaya, Kailashahar, for their valuable effort to make the webinar in the current shape. Also, thanks to Dr. Ankon Sinha, Assistant Professor, Dharmanagar College, and our technical coordinator, Simoti Mitudas, Assistant Professor of IT, constantly helping us. Last but not least, thanks to all our participants for showing their interest in this webinar. Your presence is extremely important for us in the coming two technical sessions. Hope we will find your attention in each and every moment of the upcoming technical session. Without your presence, all of our effort will go in vain. Thank you, one and all.
Thank you, sir. Thank you very much. So we are actually running short of time. So without much delay, we are going to the technical session. So now I request President of the today's conference, Sri Gautam Das, Principal in Charge to Government Degree College Dharmanagar, to declare the inaugural session is over. Sir,
Thank
over
you
to
all. Thank you. Officially, I declared the inaugural session of today's e-conference, international e-conference, and I hope within a few minutes our technical session will be starts. Thank you.
Thank you, sir. Thank you very much once again. Thank you all. Now we are proceeding second session of the first day and first technical session. In the first technical session, we have three invited talks from the distinguished, renowned educationists. Hope sessions will be very enjoyable and helpful for the participants. The sessions will be chaired by Dr. Ankar Shina, Assistant Professor and Secretary, Teachers Council, Govt Degree College, Dharmanagar. I request Dr. Ankar Shina, sir, please take over the session. Dr. Ankar Shina, sir, please.
Thank you, sir. Thank you, sir. Okay, so I'm again here. So thank you. I would like to convey my heartfelt thanks to the organizers, all the organizers, for providing me the opportunity to show my duty toward as a chairing the chairperson of this session. So thank you all. And before going to start the technical session one, I would like to clarify few points that for the participants also, that I would like to give some outline about the technical session one. That is, first of all, we will witness the three extraordinary lectures which will be given by the eminent professionals from the field of physics and teaching technologies. After each lecture, we will have some interaction sessions which will be question asked by the participants. I will put forward the questions in front of the resource persons so that we have fruitful interaction between participants and the resource persons. That will be for 4 to 5 minutes. For that, before starting anything, I would like to request the participants and give you some information instruction about that. I due to the time constraint, we will ask only 4 to 5 questions. But at the same time, I would like to assure you that whatever the question maybe you are having, that will be answered by the resource person through mails and any other social platforms. So don't worry for that. You will get your answer directly or indirectly. So after completing every every lecture, we will have interaction for 5 minutes. Interaction, you would say, in the form of question answering session. And after completing all the 3 lectures given by the resource persons, I will summarize the whole lectures or the technical session. So that is the brief outline about this technical session. Now, okay, so now we are going to start the technical session. The first lecture, or the presentation or the deliberation, which will be given by the first resource person. She is Dr. Munira Jannatul Kobra. She is presently working as an associate professor, Department of Physics, University of Rajshahi, Bangladesh. She was awarded with her PhD from Kyushu University, Japan. She excelled in her research work by visiting IIT Kharagpur as a visiting scholar consecutively for 2 sessions in 2019 as well as in 2020. She has numerous awards in her form of scholarship and fellowship in her name. She got SGR International Research Scholar and Ashok Dev Sarkar International Scholarship from IIT Kharagpur, India. She also got YKK Leaders 21 Scholarship for doctoral studies in Japan. From this, she got more fellowships like UNESCO, IAFA, and NSICT for her higher studies. Being a professional, she got membership from American Physical Society as well as from Bangladesh Physical Society and OWSD. She published more than 5 papers in reputed international and national journals. So without any delay, she is going to present her presentation or lecture on a topic known as Nuclear Physics, Introduction to an Intranuclear Cascade model for nuclear reaction. So I welcome you, madam, and you can proceed, madam. Thank you, madam.
Thank you very much. Should I share right now?
Yes, madam. Yes. Once you share the PPT, then I will remove myself from the stream. Okay, madam.
Can you see my screen?
Wait, madam. Yes, madam. It's all right. Perfectly okay.
Thank you very much for your kind introduction. Honorable chief patrons of the faculty members, distinguished personalities, PhD students, research scholars, bachelor and master's students, and of course all the organizers who worked very hard to arrange this program. A very good morning. I think it should be noon time. Yeah, very good noon. Thank you very much for inviting me for this talk. I appreciate highly all the organizers, especially the Department of Physics, Dharamnagar Degree College, for this initiative and for arranging this e-conference. Thank you very much for inviting me as a speaker. Basically, I've been asked by the organizers to say something about my department, my institute. So I will go for that first, then I will start the academic talk. You can see the title of my talk, Nuclear Physics, Introduction to an Internuclear Cascade Model for Nuclear Reactions. So during this talk, we will try to learn, just starting from basic nuclear physics, a nuclear reaction model that is very much important nowadays. I will try to keep my speech as simple as possible because most of the students are bachelor or master's students. But I feel that there will be some food for thought for people in advanced stage. So I belong to Department of Physics, Rajshahi University, Bangladesh. The department was established in 1958. It is situated, you can see the picture, it's Satyendranath Bose Academic Building. It offers bachelor, master's and PhD programs. Almost 90 students get enrolled every year in bachelor program in our department. There are 25 faculty members in our department. You can see some of the faculty members here. We 4 among them are female faculty members. You can see one of our esteemed teacher, Professor Emeritus Arun Kumar Bashak sir, with our Honorable President of Bangladesh. And here is our chairman sir. So our department has long tradition of research. We do have very strong group in condensed matter physics, nuclear and atomic physics, and material science group. There's a small group also in medical and health physics and high energy physics. So we faculty members have collaboration with different research groups in different part of the world, like USA, UK, Japan, Algeria, South Africa, India, etc. So you can see some of the name of the institutes where we do collaborate. So our faculty members has mainly post graduations from UK, Japan and Rajshahi University, and from some other countries also. So the question comes, where do we publish? So one of our faculty member has publication in Nature. 2 have publication in Physical Review Letters, but these are mainly during their postgraduate research work. But we do every year publish good number of articles. You can see some of the journal name here. These are reputed journals. Even last year, our department number of publication was around 50 or more than 50. Yes, more than 50 it was. So as like any other institute, we also take students evaluation at the end of every academic year. Based on that evaluation, one faculty member gets Teacher of the Year award, and based on research publication, one faculty member gets Researcher of the Year award. We do have around 450 students. Among them, 20% are female students and a good number of alumni because it's a old department. Many students have been alumni are working in academia in home and abroad and all other sectors. Also, you can see some of the photo here of our running students. Here is one activity. I mean, we do have also very active alumni association. This is one activity from the alumni associations photo. So like other institutes or all over the world, we also shifted our academic activity in Zoom platform, like online platform. Nowadays we are missing in-person activities, but we are connected with our students through Zoom platform. So Rajshahi University is the second largest university in Bangladesh. Just 4 days back, we celebrated 68th birthday of our university. It has around 1,200 academic staff, 2,000 administrative staff, and around 30,000 students. Total campus area is around 753 acres. So you can see here a map. This is Bangladesh. I know you are watching me from some different part of Tripura, somewhere here, and I am talking to you from somewhere here, from Rajshahi. So our university has 59 departments under 12 faculties and 6 institutes we do have. So you can see here name of the faculties and institutes. Sorry, this is a mistake. This should be 12 faculties. We do have some interested students, though the number is very few, from these countries, Nepal, Somalia, Jordan, India. But the good thing is that number is increasing. So what's the research output of our university? Especially the faculty members may know that SIMAGO annual ranking they published by Scopus database. Basically, this ranking is based on Scopus database. So according to this ranking, in 2019, Rajshahi University ranked first based on research. But in overall ranking, Rajshahi University usually stood among 3 to 7 rank among all public, not only public, among all universities in our country. So here I just tried to put some pictures so that you can have idea about our university. We do have 6 academic buildings, 18 dormitories, and some other facilities, of course. So this is a academic building. This is another academic building. This is a student hostel or student dorm. This is basically for male students. It's a Shohid Minar. This is just roadside cafe where students usually gather. And this is the main gate of our university. So now I move to my academic talk. So here is the plan of my talk. I will first try to explain why one should study nuclear physics or what is nuclear physics also. Then I will try to explain some basics of nuclear physics. Then I will explain a nuclear reaction model, that is intranuclear cascade model, that is my research. Then I will show you some name of the top nuclear physics study or research facilities around the world. So the question first comes, what is nuclear physics? Nuclear physics, basically the study of atomic nucleus under normal conditions or in excited states. Also, the study of interaction among them. So atomic nucleus sits in the core of matter. Also, it provides fuel to the stars. We get energy from sun, and that is because of nuclear reaction. So through nuclear research, we get carbon-free energy, better healthcare, as well as improved national security. Besides this various application, this nuclear physics is strongly related to other fields like field theory, atomic physics, astrophysics, cosmic chemistry, or geology and archaeology. So nuclear physics has various applications. I just here put few of them. In case of industrial or analytic applications, we say nuclear radiation can be used to preserve food. Using irradiation technique, we can keep preserve food for a longer period of time without hampering any taste and freshness. Nuclear radiation also used to sterilize single-use medical devices, because radiation can kill germs or bacteria that may cause disease. So this technique is cost effective and of course safe. So in case of nuclear medicine, we can say that discoveries of atomic and nuclear physics is closely related to the improvement of nuclear medicine. And you may know some of the applications. You have heard the name that CT scan, PET, radiation therapy, these are applications of nuclear physics. So another thing is that, okay, we can get energy, right? We can get energy from nuclear power plant, and that is of course based on nuclear reaction. What kind of nuclear reaction? That is fission. That means a heavier nucleus is split when it is bombarded by a neutron, because neutron, for example, a neutron hit a heavier nucleus. What happened? It splits and it releases energy. Neutron does not have any charge, so it doesn't feel any Coulomb barrier. So it just splits and release energy. That energy, that is the basis of energy from nuclear power plant. India does have 25 to 26 nuclear power plant, and you may know that Bangladesh also is entering into the nuclear power plant era. Another energy source is nuclear fusion reaction. What is this? For example, two lighter nucleus come close together, they fuse and release energy. So, but there is some technical difficulty still. What kind of difficulties? Two nucleus, that is, for example, charged particle comes together, so close together, they feel Coulomb barrier. So there must have some kind of kinetic energy so that it can penetrate the Coulomb barrier. So this kind of kinetic energy sometimes is given by heating. So now still the research is going on, but we believe that maybe within 3 or 4 decades later we may get energy from nuclear fusion reactor. So if any students are interested, you may go through this book, Nuclear Physics by John Lilly, to know more about applications of nuclear physics. So I will just try to explain some basics of nuclear physics now. So until 19th century, we had a belief that, okay, we had an understanding like that atom is the smallest unit of matter. In 1897, J.J. Thomson discovered electron, and he imagined a model that atom is like a positively charged paste, and electrons are embedded within that paste, like plum pudding. Like I mean, say that plum is embedded in the pudding. Maybe we don't understand this, but we can think that way, that okay, if atom is a spherical cake and raisins are embedded in that cake, then raisins are electron, or atom itself is the cake. This is the positively charged. So this was Thomson's thinking. But in 1911, Rutherford, Geiger, and Marsden conducted that famous alpha scattering experiment. So what they did, okay, they put target like thin foil, but don't. This is very much. I mean, this is not like foil. Thin foil is much thinner than this one. But the idea is that okay, they put a target like thin foil and they start to bombard by alpha particle that foil. So what will happen if the atom is like, I mean, Thomson's model? Then most of the alpha particles should have come back, right? So, but what they found that okay, most of the alpha particle is going out, only few, maybe 1 out of 8,000 alpha particle is coming back in large angle scattering. So Rutherford concluded that there is something positive heavy where all mass of the atom is concentrated, that is nucleus. And later on in 1932, Chadwick discovered neutron. So this is the article that was published by Geiger and Marsden of this experiment. So atom, what is atom? We can say the nucleus sits at the heart of the atom, right? So a nucleus consists of positively charged proton and neutral neutron. And the whole mass of the atom is concentrated in the nucleus. So the question comes, okay, why protons being positively charged sits together inside nucleus? Why? What's the force is responsible for that? So until then, only gravitational force and electromagnetic force were known. So if the gravitational force was responsible for that, then okay, we can measure, okay, what's the strength of these two forces? So if you measure electromagnetic repulsive force like 1 divided by 4 pi epsilon naught q1 q2 divided by r square, and gravitational force is like the expression of gravitational force is universal constant g times q1 q2 divided by r square. So if you put the values, and you also can get these values, that electromagnetic repulsive force is much higher than gravitational force. So for sure, gravitational force is not responsible to bind the nucleus inside nucleus. So there must have something more stronger force that keeps nucleons inside the nucleus, and that is the nuclear force, that is strong nuclear force. And this force has some property like it has short range, like around 1.4 femtometer, and when it comes very close to nucleus, it also feels repulsive core. So short range repulsive force feels at 0.7 femtometer. Nucleon feels this repulsive core when they come very close. So you can see here some size of the atom, nucleus, proton, quark, electron. We know that proton has also internal structure, like quark is inside the proton, but electron doesn't have any structure. You can see atom and proton size, if you compare that, nucleon is around 100,000 times smaller than the atom itself. So let's think, put this. We can compare the size in some other analogy. For example, if we consider the gold atom nucleus has a radius 1 feet, okay, then the outermost electron of gold atom will be at 3.3 mile apart. In the same way, if we consider sun has 1 feet radius, then the outermost planet will be at 1.6 mile apart. What can we understand from this analogy? That atom has huge empty space. So using experimental arrangement like bombarding electrons, high energy electrons, we can also measure the nuclear radius. And nuclear radius has a strong connection with the mass number. You can see R is equal R naught A power 1/3. So what can be the radius of a nucleus? For example, if you consider, okay, for example, 27 aluminum, if you put the value A is 27, R naught, this is experimentally determined value, this one, then you will find the radius of the aluminum nucleus will be 3.75 femtometer. I think you know, especially bachelor students, just femtometer, 1 femtometer equal 10 power minus 15 meter. Bomber. So another thing is that, okay, experimentally we can also find the charge distribution inside a nucleus. This is from center to nuclear radius R, and this is the charge distribution. And what we find that, okay, the charge density is quite constant inside the nucleus, and then it reduces almost sharply. So what does it mean? It means that nuclear force is short range. It just interacts with its nearest neighbors. But why the density is not higher at the center? Because nucleons have also, it feels repulsive force, because nuclear force is repulsive at very short distance. That's why we don't get higher density at the center also. So what is nuclear binding energy? For example, if you measure nucleus, you find the mass of the nucleus is smaller than its constituents. For example, you can see this nucleus has some mass, and if you measure the mass of these constituent nucleons, you will find that the separated mass is greater than this nucleus itself. So there is some missing mass. The equivalent energy of missing mass is binding energy. Or in other way, we can say that binding energy of a nucleus is the amount of energy needed to separate all its constituent nucleons. This is kind of experimental proof of Einstein's mass energy equivalence also. So you can calculate binding energy using this expression, or using this expression. This is the mass defect. So binding energy per nucleon curve. You can see here that binding energy per nucleon for lighter nuclei is low, then it increases, and then at certain value, this is the maximum, here the maximum, then the binding energy per nucleon starts to decrease. So what can I understand from this curve? We know that in fusion, two nucleus fuse together. So for example, if two nucleons fuse together, for example, deuterium and tritium is fused together and it creates helium-4, you will see that it has larger binding energy per nucleon. That's why in fusion reaction, there is release of energy. And that release of energy, this is also the origin of energy production in stars. In sun, their fusion energy is continuously happening. That's why we are getting energy, huge amount of energy. In fusion reaction, what happens? A large nucleus or heavy nucleus splits into some kind of here in some comparable masses. So heavier nucleus, you can think that this nucleus has binding energy per nucleon less than its product nucleus. The product will be somewhere here, right? You can consider the binding energy per nucleon here around 8.7 or something, and here you can see the binding energy per nucleon for uranium will be less than its product nucleus. So we can understand that why we get energy when uranium splits. That means in fission reaction. This principle is the basis of production of energy in nuclear power plant. Another thing we can find here that is, for example, you consider here oxygen 16. Here, this is oxygen 16, or somewhere here, for example, you can consider a nucleus that has 20 mass number, and a nucleus here almost similar, maybe 125, that has 125 mass number. This also has almost similar mass number, right? So one nucleus has 20 nucleon, another nucleus has 125 nucleon, but binding energy per nucleon is same. What does it mean? That means nucleon doesn't feel whether there is more nucleus or whether there is less nucleus. That means nuclear force is only affected within its nearest neighbors. That means one nucleon only interacts with its nearest neighbors. So that's why nuclear force is saturated. So radioactive decay, you know that radioactive decay is the spontaneous emission of radiation by unstable nucleus. Henry Becquerel discovered radioactivity in 1896. Basically, with the discovery of radioactivity, nuclear physics itself born. And later on, Ernest Rutherford discovered three kinds of radioactivity: alpha emission, beta, gamma. Alpha particle means helium nucleus. Beta is either electron or positron. Gamma is high energy photon. So this is the book that is very first written on nuclear physics. It's 1904 edition. So Rutherford first wrote a textbook on nuclear physics. So you can see here how we represent is basically a nuclear reaction. You can see here, and also we can represent a nuclear reaction by this way, right? So there are various kind of nuclear reaction like elastic scattering, inelastic scattering, radiative capture, nuclear fission, or some other nuclear reaction also. What happens in elastic scattering? That a projectile hits the target, and that means projectile and target is same, and the target nucleus left in ground state. But for inelastic scattering, what happens? Same like elastic scattering, but here the target nucleus left at excited state. In radiative capture, the outgoing particle is gamma particle. And in nuclear fission, that means heavy nucleus splits in two comparable mass. But there is another kind of nuclear reaction, that is many body reaction or spallation reaction. What happens in spallation reaction when a particle comes with high energy to the target? So outgoing particles, there are various outgoing particles may emit. That is called spallation reaction or many body reaction. So just keep in mind, I will discuss about this reaction later on more. So I just want to give you an idea that nuclear physics studies and application from the beginning or from earlier, it was carried out based on low energy physics. I mean, in low energies, scientists are carried out the nuclear physics studies or application mainly. But nowadays, in modern studies, have been shifted towards higher energies or intermediate energy. Why? Because intermediate or higher energy region has great practical application, like in energy generation or in cancer therapy. I'll talk more detail later on. So now I come to my point, research. So what we really do? For example, let's first discuss this reaction. This is an incident particle hits the target nucleus. Right? This is proton hits the target nucleus. Then it emits number of particles, right? But the target nucleus left at excited state. This is the residual nucleus. So it has some excitation. How it remove its excitation? It may emit some other particles or may splits into product nucleus. That is, maybe there can happen in fission reaction, or maybe there can happen just the excitation. That means emission of some other particle. So what does it mean? This kind of nuclear reaction has two stages. One stage is, this is the very fast. First means it happens very quickly. That is, times is 10 to the power minus 22 seconds. What is the second stage? Second stage is the excitation stage. This is called evaporation stage. What we do calculate. I mean, our main target, main research is to calculate these stage nuclear reactions. And this is calculated by other model that is called evaporation or fission model. So to calculate this stage, there are various models like Goldberger, Bartinian, some higher. All are commonly called INC model. The INC means intranuclear cascade model. So who proposed this kind of nuclear reaction is two stages? This is Mr. Server in 1947. He proposed this mechanism. So just an overview of the INC model, how it works. We just create a target nucleus, then we hit by a incident particle. When incident particle enters into the nucleus, it interacts with nucleon, then find a straight line trajectory. Then when it comes closer to a certain distance, then it will interact with that another nucleon, and that's how it occurs, and it emits some particle. This is very minimum, I mean, INC, original INC models overview. So what we really want to do, we want to improve this projectile. For example, for single, we want to improve to cluster or complex particle. Why complex? Means it has the incident particle when it has more than one or two nucleon, we call it a complex particle. Like, we want to improve this model so that it can be applicable for deuterium, alpha, or carbon, etc. So why we do? I just want to explain some applications. Like, okay, the conventional nuclear power plant has some.
Excuse me, madam.
Yes, please.
Excuse me, madam.
Yes, please. I mean,
there may be slight means network issue maybe. So can you please explain from the last slide, just before that, is that model? One more slide. Yes, madam. From here, you can continue.
Thank you very much.
Still, madam, your voice is not clear still. But okay, madam, you can continue now.
Is it still breaking?
Slightly improved, but it's okay, madam. It is adjustable. Audible.
Should I change my network provider or something? Can you just make sure?
Yes.
Is it okay? Can I continue this way, or I should do something?
No, madam. It is okay now. Okay. Otherwise, you can use. Otherwise, you can use earphone also, madam. Or maybe.
Yeah, I'm using. I'm sure. Okay. Am I audible better?
Yes. Yes, ma'am. Yes, ma'am. Okay.
I'm sorry for the network issue.
No
Sometimes
problem,
it
madam.
happens. Okay. So, what's the basic principle of INC model? We create a target nucleus. It hits we bombard a incident particle. When it go inside the target nucleus, it will interact with the target nucleons, and after each interaction, it will follow a trajectory, straight line trajectory. So when the at what distance it can interact. For example, if two nucleon comes some closer distance than this distance, then it will interact. This is very basic principle of INC model. So what we do, we are trying to improve this model for other projectiles. That means some complex particle. What is complex particle? That has the particle that has more than one nucleon, like deuteron, alpha, carbon, etc. So why we want to improve this model for complex particles? Okay, I can say you some applications. So we get energy from nuclear power plant, that is very much clean, carbon free energy, but still it needs some improvement. So one of the technology is ADS technology. Extensive research is going on this technology. What's the principle of this technology? There is an accelerator that accelerates proton. That accelerated proton hits a spallation reaction, and that will emit some neutron. That neutron will initiate the chain reaction in the power plant. That means the nuclear reactor will be in subcritical stage in this technology. So what will be the benefit for this technology? If you stop the accelerator, the reaction will be stopped. I mean, chain reaction will be stopped. So it will improve the safety of the power plant. So another issue with the nuclear power plant is that to handle the high level radioactive waste, because high level radioactive waste has around 10,000 years half life. So what we usually do, that we just kept it in underground for 10,000 years, and it is really costly. So in this technology, the idea is to transform or transmute the high level radioactive waste into a low level, in a lower half life waste. For example, if the radioactive waste has 10,000 years half life, it will reduce the half life to maybe few hundred years. So it will reduce also cost, and it will be easier to handle. So this technology is will improve our power generation. But to optimize this technology, you need some kind of code. I mean, that is called transport code. And transport code, for example, before starting, a power plant or something, we need to calculate it by simulation or something. So that needs a code that is transport code. And transport code uses this kind of nuclear model. INC is one of the important model for transport code. And that needs also, for example, this proton will hit the spallation target, and there will be some alpha particle, deuteron also will be emitted in secondary. It will be emitted, and that will create that will initiate another nuclear reaction. So we need to calculate that also. So INC model improvement is needed. Another thing is that heavy ion cancer therapy, usually for cancer treatment, X-ray or gamma ray is used. So what happens? It will really, when there is some kind of deep rooted tumor, so you will get reduced dose if it is deep rooted. But if you use particle therapy, what will happen? You will get at some well defined depth maximum energy. This is called Bragg peak. But if you use, for example, some heavier particle like alpha or carbon, so what will happen? The maximum dose at Bragg peak and the ratio of maximum dose at Bragg peak and the entrance level dose will be higher for heavy ion cancer therapy. So now research is going on for heavy ion cancer therapy. So that is also needed to calculate before the dose, before cancer therapy. We need INC model also. So this is a particle transport code. That's what I am telling, that if transport code is needed, almost, maybe I will take 5 minutes more. Okay. So particle transport code uses, you can see here, there are various models. This is a particle transport code. There are various models. One is INCL model. This is the default model of INC model. Okay, default INC model, but this model has some difficulties. So what we want to overcome that problems what is faced by this INCL model, and our model is INC-ELF. So I can show you some problems of the usual INC model. You can see for cluster induced nuclear reaction like alpha particle induced nuclear reaction, this is the experimental data, and this is the emissive energy, this is double differential cross section data. It is not, it cannot, the model cannot reproduce very well these experimental data. So I'll just, there are a lot of calculations here. I'll just simply say what idea we put actually to solve this problem for projectile incidence. Just we think that, okay, if target particle is coming towards the, incident particle is coming towards target, so due to nuclear potential, it will break up, and that nucleon also interact with the target nucleus, and it will go out. Another thing is, consideration is that this incident particle will bend due to nuclear potential. So this idea has been included. You can see some calculations here, and we get almost, this is kind of result. Due to time, I'm not going through or more details. This is calculations, very simple idea, but you need to calculate it. So we get more or less good result. But these are, you can see some other model result. These are our model result. You can see the experimental data has been reproduced by our model, but these models could not reproduce well. Okay, these are the results. So now I will show you, especially for the students, some facilities or study facilities or research facilities of nuclear physics. For example, in Canada, TRIUMPH is one of the top research facilities for nuclear physics students or subatomic researchers. In USA, Michigan State University is the top university for nuclear physics study or research. In Japan, you can RIKEN or RCNP, very good facilities. In Italy, INFF. These are very few research facilities all over the world. I just want the students, okay, you may in your free time just Google and see what's happening around the world. Read. It will motivate you. It will, maybe at the end you will find interest to study nuclear physics. Then you will find interest that, okay, over time you may contribute for the society something. That is really, every person's wish to do something for the humankind, and being a researcher, we can do it very well. And thank you very much. That's it. Thank you.
Thank you, madam.
Okay.
Madam, you can stop the sharing also.
Okay.
So that.
Sure. Oh, sure. I'm sorry that I took more time. Sorry.
No problem, madam. Means it was a nice experience to hear you. So before concluding, I will ask the participants to clarify their doubts in the form of questions. So meanwhile, we got few questions from the students. That
Okay.
one question asked by Amal Devnath.
Mm-hmm.
Maybe the student is asking that, should nuclear power plants be sited underground to help contain radioactive releases? Should
No.
okay.
No, yeah, I think I got it. Actually, nuclear power plant, if you go this, with a detector, you will find that there is no radiation. So it's really safe. But what's the problem I mentioned is that high level, it is difficult to handle the high level radioactive waste. We get some waste, right, after the fission reaction. That is difficult. because it has half-life around 10,000 years. So you have to put it underground for 10,000 years. That is very much costly also. That's what I mentioned. But nuclear power plant is quite safe. There is no problem if you go in near a power plant. You will not be radiated at all. Thank you very much.
Okay, thank you, madam. Thank you. I think you are satisfied with the reply. One more question, which is asked by Ashtumita Dev. Uh, does nuclear radiation hamper the quality of foods, or is it good to eat those food which are preserved by nuclear radiation? So
Thank
she is
you. Thank
asking
you
this
for
question.
your nice question. It's basically in this technique, what kind of radiation is used? Low energy electrons. So it is quite safe and there's no harm at all, because it is cost effective also nowadays. This technique has been used to preserve food. Maybe you can preserve food for even 1 month also without any problem. It will keep the taste and freshness also. No problem at all. Thank you.
Okay, thank you, madam. I think the last question, which is asked by the faculty members, I think, of physics department, can most nuclear reactions be reversed? Can be reversed? Can,
Nuclear reactions, right?
yes, madam. Can
Most
most
nuclear reactions. Can most nuclear reactions? Uh, it can be reversed. Whatever I think. Okay, some nuclear reactions can be reversed, but maybe I can be more sure and I can reply you later also to give you exact answers. Okay. Maybe I can reply you later to give you more exact
yes,
answers.
no problem, madam. Through mail you can
Yeah.
reply, madam.
Thank you
One
very
more
much.
question. One question. There are lots of questions, but we will choose only one. That this one, which is asked by Luffy. I don't know his or her name. Madam, what does thermonuclear power from fusion mean?
Basically, what I explained is that, okay, how nuclear fusion reaction works or happen. Okay, when two lighter nuclei come close together and they fuse and energy released. But nuclei are usually charged particles. So if they are two charged particles come close together, they will face some kind of, Coulomb barrier, right? So to penetrate this Coulomb barrier, the particle has to have some kinetic energy. So this kind of kinetic energy is given by heat, okay, by heating process. That's why it's called thermonuclear power from fusion reaction. Thank you for your question.
Okay, madam. So this is, I think, very important questions. Sudeep Sukleboddo, sir, maybe. As we know, electronic current is the source of magnetic moment in an atom. If so, then is there any contribution of neutron to the nuclear magnetic moment in a nucleus? This is the question by Sudeep Suklavadda.
You say in contribution of neutrons? Yeah, I think yes, of course, it does have contribution on the nuclear magnetic moment of the nucleus. Neutron, of course, has contribution. Yes, I think so.
Okay, thank you, madam. Uh, Meanwhile, yes. So, where is that question? If anyone hide the question, then it will be better. Okay. Okay. So thank you, madam. Thank you, madam, for your stimulating speech. I like the way you are explaining the things. It was really, really worthful listening to you, madam. We are hopefully we will get another opportunity to listen you again. So thanks again for accepting our request, madam. Thanks, madam.
Thank you very much. Thanks all participants for listening me. And I again say that students do study and try to learn physics, and that's it. Thank you.
Thank you, madam. So before proceeding towards the next lecture, I would like to convey some instruction to the participants. It is better to write your queries well in advance so that we can have an management of that questions and we can put in front of the resource persons. That will be better for us. Otherwise, you will directly or indirectly you will get your reply very soon through mail or through WhatsApp. So thank you to the participants. Now, we are moving towards the next lecture, which will be given by Dr. Nirmal Kumar Sarkar sir, presently working as Associate Professor, Department of Physics, Karimganj College, Karimganj, Assam, India. He contributed a lot to the country as far as research work is concerned. He published more than 73 articles in reputed international and national journals and also completed 2 minor research projects. As a true professional, he got membership from Indian Science Congress Association, Science and Rationalist Association of India, Physics Academy of Northeast India, Assam Science Society, and Indian Spectroscopy Society. He served as a member of editorial board and academic editor of Atomic and Molecular Physics, Hindavi Publishing Corporation, and many more journals. He guided 3 PhD scholars also. So today he is going to present a lecture on algebraic model in vibrational spectroscopy, a probable epicenter of spectroscopy research in the next part of 21st century. So without any delay, I will request our sir to deliver his lecture. So please, sir.
Thank you very much, Mr. Chairperson. Let me proceed towards the technical side first.
Yes, sir.
I think, Chairperson, sir, myself audible?
Yes, sir. Audible and visible also. Thank you, sir.
Okay, thank you very much. Welcome to all and good afternoon to everybody. First of all, I would like to thank all the organizers. Actually, some of them are very much close to me, like Dr. Rahul Bhattacharya, Dr. Shojit Dash, Dr. Raghunandan, and many more. And as a whole, I am very much thankful to the organizers as because I am being given this chance to talk before all of you. And actually, what it was told by the organizers to me that in this pandemic situations, in what way the research, in particular physics research, may proceed. I should narrate the first these things in brief, and later on I should enter into my actual topic. Accordingly, as it was suggested and guided or directed by the organizers, I'm proceeding with that and what we are going to face in this current situation of pandemic, you see, regarding advancement of research in physics and teaching techniques. Actually, the COVID-19 pandemic has changed education forever. This is how it is being shown by your Reuters picture. And here, this is the picture each and everywhere, actually, what we are getting. Due to this particular perception in this COVID pandemic, millions of students had to adapt these new types of online teaching learning process. Actually, what's the reason behind it? In this change scenario in education due to COVID pandemic, the COVID-19 has resulted in schools shut all across the world. Globally, over 1.2 billion children are out of the classroom. As a result, education has changed dramatically with the distinctive rise of e-learning, whereby teaching is undertaken remotely and on digital platforms. Research suggests that online learning has been shown to increase retention of information and take less time, meaning the changes coronavirus have caused might be here to stay. Here, the next story is the main challenge that the higher education system has to face today are teachers' resilience to change and changing students' perception towards online learning. Training programs for teachers need to be developed in order to help them adapt to the changes, to help them understand, and the future of education in higher education systems involves the online environment. It is unlikely that the system will go to how it was before the pandemic, and that online teaching is a new way to interact with students. Requisite infrastructure development to achieve all possible teaching techniques in online teaching learning process for all is another vital issue in this regard. It is needless to say that physics teaching in higher education also belongs to the same track. And what is the actual picture? So far, we go for the experimental physics research during this pandemic situation. As it is known to us that physics-based techniques play a huge role in the field of COVID research. If we remember Dorothy Hodgkin, we could remember that how she got the structure of protein utilizing the help of physics, that is X-ray diffraction, and many more applications are there. Hence, the physics researchers involved in COVID research during pandemic period have been in lab on an emergency basis, but other physics researchers were encouraged in general to work from home. Actually, this will be clearly shown by the statement one PhD student from UK Research Lab, Daisy Shearer, who is in University of Surrey, United Kingdom. What she told, returning to the lab will be hugely beneficial for me. That means she was not in a position to go to the lab for doing the experimental things for her research. In this light, actually, this is the general statement. This is not only the statement of Daisy Shearer, rather it is the general statement of the experimental researchers in physics all around the globe during this COVID pandemic. And of course, during pandemic or post-pandemic, we should try to join a good institute for research work. If we see in terms of India, all are present here, as it was told by the organizers and advised by the organizers to me, that our target group will be mainly the undergraduate, postgraduate students. Hence, I again reiterate that what I'm saying, basically targeting the postgraduate or undergraduate students or the fresh research scholars. In that light, from this particular National Institutional Ranking Framework by the Ministry of Education that was published in 2020, that's just last year, from this link, one can see which are the best universities in India. Here, only just first few, say 14 universities, it has been shown here, where you will find Jadavpur University, Calcutta University is also there. Of course, in our northeastern India, Tripura University, Govt University, or Northeastern Hill University, they're also claiming some good positions, including Mizoram University also. Anyway, it can be seen by the students from this link. And what about for the others, global scenario? Just before me who was talking, Miss Kubra, actually she is from this institute, the Kyushu University, where I had been during 2007. It is in the Fukuoka city of Southern Island, Japan, Kyushu, the largest city, of course, in that Kyushu island. And it is background, this is the Kyushu University, one building. And here you see, regarding the scope of physics research in India and abroad, what is the present day scenario? To give a broad overview, scope and facility of research in theoretical physics is now world-class facilities available in India. To do good research in theoretical physics, one needs a good researcher as advisor, a good workstation, and a good internet connections. These things are now available in India. In experimental physics, India is yet to compete with China, Japan, Europe, US, Australia, New Zealand, etc. The reason is that in addition to the above requirements, in experimental one needs good instruments and the ability to repair those instruments. Almost all high-tech instruments from abroad, they are costly and one needs to compete with many fellow users to get slots to do measurements. So experimental research in India are not yet sufficiently fast-paced to be competitive with the rest of the world. Also, education overall does not get as much government funding in India as in some other countries, and industry's fundings in physics research in India is almost non-existent. What it has been told here, perhaps you can remember the case of Indian Association for the Cultivation of Science during the year 1928, when our Sir C.V. Raman with Kariyamanikam Srinivasa Krishnan, who is commonly known as K.S. Krishnan, developed a Raman effect, and for which Sir C.V. Raman was awarded Nobel Prize in 1930. But unfortunately, I'm sorry to say, right at this moment, standing right at this moment, actually India is looking forward. Germany, Japan, USA, Australia, like such countries, Canada, actually we are seeking help from them in terms of instruments, in terms of theoretical knowledge. Actually, this is very much unfortunate for us. Actually, the item which was discovered in our country, in our motherland, for which Nobel Prize was, awarded. But right at this moment, actually, our experimental section in particular is lagging behind. And for that, all we must see so that the per capita income, that is GDP, which should be allotted in R&D sector, till now it is loitering around 0.2% of GDP of our country. At least it should be near about 2% of GDP, so that instruments, sophisticated instruments required for research purpose in experimental physics can be constructed, can be generated in India itself. Already we had a program, Make in India, under that particular umbrella. Whether it can be taken, all we must see for that. Otherwise, practical physics research in experimental lab, it is very much still now difficult for Indian land, as because till now for the sophisticated instruments we are looking for other countries. Anyway, let's proceed for the next part of this scenario. Now, more spatially, assuming graduation means a BSc degree, doing research, after that means enrolling for a research-oriented degree, some institutes, IISc, Bangalore, Jawaharlal Nehru Center for Advanced Scientific Research, that is JNCASR, that is also in Bangalore, ISRs, and so many ISRs now are there. Nearest one is in Calcutta, all we know, and so many institutes like that in India are there, offer a Master of Science by Research, 3 years generally. Some institutes offer an integrated MSc cum PhD program, usually 7 years in total. The third option is to do a traditional 2 years MSc and then enroll for a PhD program, which is usually 5 years, but often takes more. And financially, if we say, nowadays the PhD scholarship offered by UGC, CSIR, Council for Industrial Research, Scientific and Industrial Research, University Grants Commission, etc., are almost at par with entry-level salaries to a fresh BTech graduate at IT companies. However, these days, the scope of a research career after doing a PhD is becoming increasingly rare. In India, the value of a PhD degree outside academia is not clear. And unlike in US, there are not much options outside academia, teaching or becoming a scientist in India. The R&D sector, research and development activity in high-tech physics related industry is still quite small compared to some other countries. This is also to be developed in our country. Now, what is my request or suggestion, whatever you say, to my friends who are graduate levels or postgraduate levels or just entering the research level, please do your research well before embarking on a path to research in India. Although, ironically, the number of researchers per 1,000 person is quite low, that is around 0.253. That is very much, poor statistics for India in research scenario. So ideally, India should have more researchers, and I do hope all will join hands with our country to enhance this particular scenario in the world map of research. And regarding research in theoretical physics, what already I narrated, it has got some specific facilities during pandemic, and outside pandemic also some facilities are there. Now, what are the plus points? No need to attend lab. It's work from home. No chance to violate government SOP. Nowadays, all we are familiar to SOPs. And after 7 days or after 15 days, government are always providing us SOPs, and we are to abide by that. And we can't move outside from our residence. We can't go to our lab, etc. And there will be no chance for that if we go for theoretical research during this pandemic. Meaningful communication with co-workers, supervisors is possible through online mode, and many more. In this light, let us discuss today a research topic in theoretical physics entitled as Algebraic Models in Vibrational Spectroscopy, a probable epicenter of spectroscopy research in next part of 21st century. Actually, I will lift in maximum places all mathematics. Simply, we will write 1 or 2 lines in mathematics. None is to be afraid about that. Simply, all you know, I'm telling the graduate or postgraduate students, already you have the idea regarding Hamiltonian, you have the idea of matrix formulations, you have the idea of eigenvalues related to matrix formulations. Simply, these things I will use. Actually, truly speaking, algebraic models, this is the, some sorts of presentations in terms of matrix formulations. And this is the main motto of algebraic models to make it popular. Let us proceed with our view. Definitely, we will proceed with spectroscopy, and definitely for that, first of all, you are to know the electromagnetic waves. As because, the spectroscopy, what we are saying, this is an interaction between electromagnetic waves and nature. And this, picture shows, and all we know, the electromagnetic waves are electric and magnetic waves. Two waves are in perpendicular directions to each other with respect to the direction of propagation of the actual wave. This is the electromagnetic spectrum. It is also known to us, we are familiar to that. And here, starting from your radio waves to cosmic rays, various, bands are shown, and where visible light and infrared, these two are shown clearly. and we will be interested with the infrared section only. And as already it was told, spectroscopy is the study of the interaction between matter and electromagnetic radiation. Here, what I told, we will be interested with this infrared sector and leaving those visible or ultraviolet or other, cosmic ray parts. With this infrared sector, our vibrational spectroscopy with what we will deal will be confined. Here, the main story, actually the figure, the photograph, what you can see, this is from the land of Maria Sophus Lee, who is actually contributed this Lie algebra, on the basis of which algebraic models is being developed later on by others. Also, he actually given that idea, and he is from Norway. And this particular photograph is also taken Norway, from Tromsø. And Tromsø, perhaps all you know, that is the most farthest university on the northern hemisphere of our globe. And from there, this here during summer session, for 3 months there is no night at all. All the times we can see the sun, and that photograph is taken during 2013. Anyway, here this is the contribution what I told Maria Sophus Lie, but that was in the last part of the 19th century. But beginning of this in physics is a little bit late, I should say. It is only the recent past we could have the use of these algebraic models. Lie algebra in your spectroscopy in particular. In physics, of course, a little bit earlier, from 1925, what we could see, starting from Heisenberg, Dirac, PM, Born, Jordan, Heisenberg, all are known to us. Actually, they initiated the matrix formulations in quantum. Quantum mechanics is there. Wave formulation is there. In a parallel form, there is matrix formulation is also there. And already matrix formulation was started since 1925. During 1930s, it was also gradually developed. Those papers, someone can see and check. And thereafter, we came, and ultimately an approach that starts from the algebra as the key tool for the construction of spectra originated in elementary particle physics in the late 1960s. And during 1970s, actually U6 algebras were first of all initiated by A. Erima. He's from Japan, and Francesco Iecello. Initially, he is from Netherlands. Later on, he went to Yale University, USA. Of course, there is another person, Roosevelt. He is also from Netherlands, but later on, he also changed his field. He is in real-time analysis. He went later on. Anyway, by this way, actually, we came to the latest part of the, Lie algebra, starting from the last part of the 19th century. And finally, it was used in spectroscopy. And how it was initiated? It was initiated first of all by Raphael de Levin of Hebrew University, that is in Israel, and Francesco Iecello, already I told. They actually initiated the introduction of this Lie algebra in spectroscopy. Raphael de Levin, first of all, gave the algebraic approach of the Morse oscillator. That was the vital and first rule which was placed by Levin. And thereafter, Francesco Iecello made the U4 algebraic model, which actually we use for the three-dimensional use and to cover the actual raw vibrational picture in spectroscopy. And already I told these different algebraic models. It was started during 1970s by Erima Iecello with U6 algebra. Thereafter, it is U2 algebra, that is one-dimensional by Raphael de Levin, and finally, that is U4 algebra or three-dimensional algebra by Iecello in 1981. And here, these are the beauty of this algebraic model to start spectroscopy. The Hamiltonian used in this approach is an algebraic one, and so are all the operators in the method, unlike the more familiar differential operators of wave mechanics. The mechanical advantage of an algebraic approach is the comparative ease of algebraic operation. There are general forms of algebraic Hamiltonians, and entire classes of molecules can be described by a common Hamiltonian, where only the typically linear parameters are different for the different molecules. Form 14 of this new model has been confirmed in the last 40 years. For molecular spectroscopy, this new model could demonstrate its suitability to address successfully even quite difficult situations. Generally speaking, this new model seems to offer a concrete and complementary technique to conventional approaches. We know those conventional approaches like using Schrodinger wave equations or Dunham expansions. Actually, for large molecules, the algebraic model could prove itself to be a competitive one to the traditional analysis. Actually, you see, this is a textbook picture. What I told that what Levin did, first of all, in 1979, just gave the algebraic formulation of Morse oscillator, and this is a best suite for the, any molecules. Actually, we know, even though we read, first of all, the harmonic oscillator type visions, later on, we know, I think, that this is not the, vibration in a molecule is not following exactly or accurately the harmonic nature. Rather, it is deviated from your harmonic nature, and it can be well explained by Morse oscillator. And this Morse potential, that's why utilized while we are using the algebraic models to deal with vibrational spectroscopy. Behind photograph, you can see this is from Moscow. This is also in 1930. Here you see the linear and bending vibrations in linear triatomic molecules with respect to equilibrium positions. You can see on the left hand side of the slide how there is some, two molecules are going away from each other and coming to each other. This is the type of linear vibrations. Of course, with that, bending vibrations is also possible. On the right hand side of the slide, you can see that, and all this can be accommodated in your algebraic models. And background photos, of course, it is from Bangkok during it is 2007, and here you see next, this is the local mode Hamiltonians. Already I told I'm not going to mathematics. This is the local mode Hamiltonian. What you can see here that can be written for triatomic molecules in terms of what you can see here, A1, A2, A12, etc. These are some constants in algebraic models, and others you can see CO41, CO42, CO412, etc. These are the Casimir operators. These were introduced in physics during 1933 by Casimir. E naught itself a constant, and what you can see the last term, this actually related with the rotational part of spectroscopy. And here, from this Hamiltonian, as I told, in matrix formulation, we can have the eigenvalues for that in terms of algebraic quantum numbers, omega 1, omega 2, tau 1, tau 2, etc. These are algebraic quantum numbers. And these algebraic quantum numbers can be written in terms of natural vibrational quantum numbers. This is your nu A, nu C, nu B, like that, what it has been shown relations. And finally, the eigenvalues of that Hamiltonian can be written like this. What it has been shown here, N1, N2, N3, these are termed as the vibron numbers for a particular bonds. In triatomic molecules, two bonds are there. There are two vibron numbers you will find that can be obtained from the spectroscopic constants, which is available in the book of Herzberg. And already I told E naught prime and other constants, and your A1, A2, etc., your vibrational constants. nu A, nu B, nu C, etc. are the natural vibrational quantum numbers. Easily we can go there utilizing the technique, algebraic models. And local mode Hamiltonian for band triatomic molecules also we can have, and that can be obtained like this, what you can see here. As told before, some algebraic parameters are there, Casimir operators are there, some constants are there, some portion of what it has been shown at the last part of the expression, that is related to your rotational part. Of course, while we will consider the vibrational feature or nature of a molecule, there we will overlook that particular rotational part. Here you see energy in energy eigenvalues in terms of matrix formulations we can have for triatomic molecules, which has been shown here in terms of algebraic parameters and vibrational, quantum numbers, natural quantum numbers, of course. And these natural quantum numbers for various vibrational states are known to us. We can have, by the algebraic techniques, very easily we can have the value of N1, N2, N3, etc. from spectroscopic constants, algebraic parameters, from some given bands. Easily we can know. In a similar fashion, suppose three equations are given to you, three unknown are there. We will have some known equations for some known bands. If we have three unknowns, three equations will be sufficient. After that, we will set this in terms of your least square fitting for a better result. In the backside, what photograph we could see here, this is from the redwood tree forest of San Francisco, California, and perhaps to all of us it is known that redwood tree, the tallest tree in the world. And that photograph was taken during 2011, July, of course. And intermode couplings in U4 algebraic models. This is another important thing. Actually, when there are intermode couplings between, various bonds are not very much prominent. There we say a molecule is a local molecule. When these are prominent, we say these are, not local molecule, but normal molecule. If we want to describe a normal molecule, in that case, we will have to proceed to have another operator that is called Majorana operator. And in terms of Majorana operator, considering the local molecules, that is considering the, those intermode couplings, we go for local to normal transition, and this Hamiltonian in new form takes this form, and utilizing this Hamiltonian, we can go for study the various vibrational spectra of your normal molecules, where intermode couplings are very much strong. Local to normal transition, how we can see or how I can understand. Actually, there is a term that is called locality parameter, which is defined like that. And there, if two bonds are there, two locality parameters will be there. J1, J2, and if we take the square root of the product of this J1, J2, we will get the value of exact locality parameter. If it is near about 0, we say for that molecule the feature is local. If J goes near about 1, we say intermode coupling is very much strong and it will follow the nature and feature of local molecules. Actually, these are the various forms of vibrations. These are the various forms of vibrations in band molecules like water molecules, symmetric stretching, asymmetric stretching, and various types of rocking, scissoring, twisting, wagging. Scissoring, what I told, the bending structure, this is similar to like that. And while we are considering the vibrational spectroscopy, mainly we will consider the symmetric stretching, asymmetrical stretching, and bending vibrations, which are contributing a lot or lion's share in the spectral scenario. Actually, these are some features, calculations. You see experimental and calculated results for various vibrational bands in hydrogen cyanide. This paper was published in 2006 in Molecular Physics. these are very much close to each other. Actually, this is the beauty of algebraic model. Using very less number of parameters, we can have a good accuracy, unlike the traditional approaches. This is another paper which was published in European Physical Journal D during 2009. This is for your OCS, carbonyl sulfide. And here also you can see how beautifully algebraic model can, accommodate various experimental results. These are some publications during that era, within 2010. These are some publications on algebraic models, and if you go with those, you will be able to find, how it is possible utilizing algebraic models in its befitting manner to accommodate various vibrations, particularly vibrational structure, vibrational scenario of different molecules using very less number of parameters. Next, let us proceed for linear tetraatomic molecules. For that, local Hamiltonian, what we see in the slide, this is given exactly alike. Here you can see some algebraic parameters more in number only, otherwise Casimir apparatus are there like that. Initially, you not the constant what it was shown for triatomic molecules, exactly same. Actually, we will see here linear triatomic molecule with examples. Monofluoro acetylene, HCCF, or deuterated acetylene. And here you see the structure. This is the linear structure of HCCF. These are the bonds, how it is being, visible there. And behind picture, you can see this is Fukuoka Tower. This is, I told you initially, this is near Kyushu University, Japan. This was also in 2007. Anyway, here we see in linear triatomic molecule, what is the feature of linear vibrations. For tetraatomic molecule, it is also same, this particular linear vibrations nature and feature. Of course, along with that, bending vibrations are also available. And here also in a similar fashions, we can go for local Hamiltonian, and from that local Hamiltonian of tetraatomic molecules, we can have the eigenvalues like that for HCCF or HCCD, and we can find the spectrum, vibrational spectrum for that particular molecule, knowing the various values of vibration numbers, which we call N1, N2, N3, etc., natural vibrational numbers, nu and nu, etc., and algebraic parameters A1, A2, etc. What I told already, we can have utilizing some known equations. And for your that is your deuterated acetylene, ACCD. Also, we can have the eigenvalues like this in terms of vibration numbers, natural vibrational quantum numbers, algebraic parameters, and from there we can go for the vibrational spectra and dissociation energies. This is another important factor. We can have the dissociation energies for molecules also in a very easy way using the algebraic model. What it has been shown in dihaloacetylenes with equivalent and different halogens, and in a similar fashion we can go for that, and from local Hamiltonian we can proceed to find the energies, vibrational energies, as well as the dissociation energies. And we will show some papers where you can have how dissociation energies can be obtained directly utilizing these algebraic models. Here are some tables where you can see for HCCF how experimental and calculated values are very much close to each other for various bands. And this paper was published during 2008 in Molecular Physics. And here also you can find for deuterated acetylenes how experimental values and calculated values are very much close to each other, and what it is obtained utilizing the algebraic models, of course U4 algebraic models. And here very less number of parameters are required with respect to the traditional approaches. And these are some features of FCCF, that is monohalogenated acetylene, and this are dihalogenated acetylenes. Here also you can see how nicely and beautifully the experimental and calculated results for various vibrational bands are very much close to each other. These are some publications what I told. This is during 2016, and next one it is in 2019, and here all 4 atomic molecules, linear 4 atomic molecules are dealt, along with the dissociation energies also were calculated. And what I told, then during pandemic situations, easily you can go for theoretical research without facing anything. Here you see these 2 papers are published during this last pandemic 2020, and for those publications I need not to proceed outside the room. Only laptop, a good network, and some good sources of papers is sufficient for that. Anyway, from here you can find how beautifully we can go for dissociation energies or various vibrational energies for linear triatomic molecules. And next, what I told, 2 models are there. This is U2 algebraic models, which was introduced by Raphael de Levin. Actually, what happens for bigger molecules, when we want to have the global scenario of vibrational picture only, in that case, instead of going the 3-dimensional picture, that is U4 model, we are interested to go for U2 model, as because till today, beyond triatomic, rather quasi-linear tetraatomic molecules, we can't proceed with the U4 algebraic models, is because after that the matrix formulations become so much complicated. Actually we are waiting for you people, new generation people, so will come and take and shoulder the responsibility to go forward with this U4 algebraic models. Practically for U4 algebraic models, entire kingdom of this particular molecular vibrations of various molecules are left untouched, and you have the golden chance to enter into that region. But if we want to proceed for other larger molecules, in that case we will have to do it, and that's why simply considering the global scenario of vibrational feature or nature and neglecting those raw vibrational picture, we can go for U2 algebraic models. And in U2 algebraic models also Hamiltonian, in a similar fashion we can write like this, and we can have the Hamiltonian in U2 algebraic models in case of triatomic molecules in these fashions in general form, and from there we can have the Casimir operators for say Ci, that is C1, C2, C3 like that, or C1 to C1, 1 to C21, C23 like this. We can have from this. This is similar to that previous one, and from here, from these tables, you can find the results. These are very much close to each other, and simply utilizing very less number of parameters, you can reach these results for various vibrational bands. This is the beauty of algebraic models, and these papers were published during 2009, 2010, and this is another one for SNBR4. Everywhere you will be able to find, we can go for various calculated results to compare with the experimental ones. Also, we can go for some predicted results, what we can see from this particular table. Later on, experimental research follow the footprints so that easily they can reach there. And you see, this is another for CCl4. This was published also in 2008. And these are some other publications during your 2009, 2010, and 2009. This is another, you can find 2012, and so on. From here, you can have an idea regarding how algebraic models, that is U2 algebraic models, can, approximate, can accommodate various larger molecules, even fullerenes, Buckminster fullerene, which is not possible till today with the traditional approaches. This is a very much unique beauty for this particular model. we are coming into the last point of our talk. This is the summary. The Lie algebraic approach in the study of the vibrational spectra of molecules may be treated as a viable alternative as well as a complementary technique to that of the traditional approach. For large and complex molecules, the approach may be a competitive one to the traditional approaches. More or less, the entire kingdom of molecules is left till today before the Lie algebraic approaches. Hence, here is enormous scope for the new researchers to build their research career in the next part of the 21st century. And in acknowledgement part, I would like to remember my friend, philosopher, and guide. He may be known to many of you. He is late Professor Ramendra Bhattacharya. And I got various helps, and many more helps at my introductory level of research from Francesco Iacchillo of Yale University, Nicola Manini from University of Milan, and Stefano Oss from University of Trento, Italy. Renato Lamas is from Mexico, Universidad Nacional Autónoma. And of course, you can see here, our convener is here, Dr. Raghunandan Das, Jaideep Chaudhary, Rupam Sen, Ashim Kallan, Dr. Srinivas Rao. I'm very much thankful to them, and we work together till now. We are very much close to each other on our mission to go forward with these algebraic models in vibrational spectroscopy. And finally, thank you all for your patient hearing. And backside picture is the Sky Tower of Auckland, photograph taken just in 2019. And last of all, wish you all the best for your future research. Background picture, of course, from Sonoma County Doubletree Hotel. And I do hope that all will be able to proceed for their best future in research field. And finally, I would like to thank all the organizers for giving me this very beautiful platform, very important platform to share my views. My heartfelt thanks to all the organizers, all the members, and finally, I'm very much thankful to all the audiences inside and outside the screen. Thank you. Thank you very much.
Thank you, sir. So meanwhile, you can stop the sharing.
Yeah, yes, I'm doing this.
Okay, sir. So, thank you, sir, for such a wonderful and elaborated session. Now we got huge number of questions from the competitors or participant side. So, due to the shortage of time, we will ask only 3 to 4 questions. Please don't mind the participants. Sir will reply you through his mail or WhatsApp group.
Yeah.
So you will get your answers. So the first question which I would like to put forward, that is asked by Mridul Sinha. He is asking, sir, how is spectroscopy help in spectral classification and internal structure of any celestial object?
Yeah, actually, I got his question. Actually, first of all, I will request Nridul Sinha to go with one publication I have shown here in 2020, which was published in vibrational spectroscopy. There, those molecules which were discussed, all those are obtained in celestial levels. They are actually, we know, spectroscopy actually is a fingerprint. Actually, vibrational spectroscopy is a fingerprint for each and everything. If we take the spectral notations if we analyze, if we have the spectral analysis of that, actually spectroscopy initially I told this is the interaction between matter and radiation. For classification and spectral classification and internal structure of a celestial object, if we receive the light from that, and if we classify, analyze the nature and feature of spectra of those particular items, definitely we can have the different features for different object, which will tell us. Actually, we have a database. We can compare. Suppose we are getting some hydrogen atom in celestial body, or we are getting some carbon atom in celestial body. We have our database. We have the mapping. And if we study that picture, just like it is your Fraunhofer lines, and if we study that spectra and we will adjust that with our available database, if we see that this database is common with that, say carbon, easily we can say there is carbon is there. In that way, spectroscopy, not only in that, in surface, on our surface also, it is very much helpful.
So, thank you, sir. I think you got your answer. Now, one more question asked by, it is asked by Rahul Bhattacharya, sir, that how algebraic calculation explain experimentally obtained result, how much it differ from experimental one. So this is his question.
Yes. Rahul was with me for many years in my institution. Is very much close to me. Thank you, Rahul. Actually, question is how algebraic calculation explained experimentally. Experimentally, actually, algebraic calculation is not going to explain. Rather, it gives the explanation of some experimental results. If we have some experimental vibrational bands and how we can reach there, this roadmap can be given by the algebraic calculations. What happens, why this algebraic calculations got so much importance right at this moment? Initially, we are busy with the traditional approaches, just by solving Schrodinger equations, that is potential approach, or Dunham expansions, like those things. But what we could find some barricades were there whenever we proceed for larger molecules. How those larger molecules, the vibrational scenario can be explained, for their no answer. And vibrational bands of those larger molecules could not be accommodated with those traditional models. As because in traditional models, we'll have to adjust a huge number of parameters for theoretical approach, and all the times those theoretical, for having those theoretical approach to set those large number of theoretical data, sufficient database are not available. That's why it was not possible. And finally, when algebraic models come, for example, say for monofluoroacetylene, and with 7 parameters, what accuracy we can provide for larger number of vibrational bands to explain those things, to explain the same thing in traditional approaches, at least we will have to need 21 parameters. And this is how we can explain the roadmap, how experiments are going on. We can, give the theoretical analysis of the experimental results. But it is not differing too much in algebraic models. What results we are getting, actually due to shortage of time, I could not show. So many tables I can show that there you will find the RMS deviations is rarely say 0.2 centimeter inverse, or 0.2 to 2 centimeter inverse. And we know already within 10 centimeter inverse, if RMS deviation is there, this we tell the experimental accuracy.
Thank you, sir. Thank you, sir. Now, with quick succession, we will ask one or two more questions, sir, with very quick succession. Like one more question asked by Rimi Datta Chaudhuri. She is asking that how to do the conversion and dissociation of complex molecules to simple ones and vice versa in this process, and how to obtain result in the same manner.
No, actually, what it is asked in algebraic models, the feature and nature is not exactly the same. Question is how to do the conversion and dissociation of complex molecules to simple ones and vice versa in this process, and how to obtain results in the same manner. In the very beginning, as because it was advised by the organizers to escape the mathematical parts, I did not show it here. Actually, in mathematical formulations, when we will go with algebraic parameters, first of all, we will have the Hamiltonian in terms of those parameters which will be responsible for the dissociation energies. And once we are having those algebraic parameters for dissociation energies, and we will have the expressions for various forms of dissociation energies. We will have some curves in terms of algebraic models, and the plateau of that curve will give us the idea of dissociation energy level, which we can have from that I escaped from this. Later on, if Rimi Datta Chaudhuri, if she contacts with me, I can send her the details. Okay, those papers also I have shown here. Last two parts which were published in last year, 2020, one in that is molecular physics, another most probably in vibrational spectroscopy. If those papers are seen, there also the answer will be obtained.
Thank you, sir. So, one more question with your quick words. We would like to hear you. From the faculties of physics department, they are asking that why Hamilton is so important in algebraic model. Could we move with Lagrangian also?
Yeah,
Lagrangian.
I could get the question. Actually, this is the starting point of algebraic models. In the very beginning I told since 1925, when Heisenberg, Dirac, they introduced the matrix formulations. Actually, algebraic models deals with the matrix formulations, not the wave mechanics or wave mechanical approach or the differential operators. And if we want to proceed with the matrix formulations, all we know for matrix formulations, we must go to the Hamiltonian, from where we will be able to obtain the matrix for that, and finally from that we will be able to have the eigenvalues, and those eigenvalues of that corresponding Hamiltonian will give us the energies for that corresponding molecule. That's why Hamiltonian is very much important here, and this is the basic starting point of these algebraic models. And to make this particular matrix formulations very much interesting, this is another motto of this algebraic approach.
Thank you, sir. I think all the participants are very much satisfied with your response. So thank you, sir. Thank you, sir, for your enlightening speech. It is a matter of pleasure to sit and throughout the lecture, and I found that your talk was one of the most engaging that I have ever had. So thank you, sir. Thanks for accepting our request and for delivering and sharing your experience with us, sir. Thank you, sir.
Thank you very much. My heartfelt thanks to all of you also. Thank you. Thank you.
Thank you, sir. Now we are moving towards the last presentation or lecture, which will be given very shortly. After this, we will have the report presentation. Then we will end the session here, the technical session 1 for the day 1. So now we are moving towards the last lecture, which will be given by Dr. M.J.M. Jaffin. Presently, he is working as a senior lecturer, Group 2 in Physics, Department of Physical Science, Faculty of Applied Sciences, Southeastern University, Sri Lanka. He was awarded with his PhD from Physics University of Peradeniya, Sri Lanka, and Technical University of Denmark. Presently, he is the chairman of Board of Studies, External Studies, subject coordinator of physics also. He has numerous awards in his name, like President's Award for Scientific Publication 2010, National Research Council Merit Award for Scientific Publication 2012. He worked as an editor and co-editor in the different proceedings of the seminars. As a professional, he is a member of Sri Lankan Association of Advancement of Sciences, Institute of Physics, Sri Lanka. He published around 19 papers in reputed national and international journals. Today, he is going to deliver a lecture on conducting polymer soft actuator or artificial muscles, synthesis, characterization, and bifurcation. So I would like to welcome him, and sir, you can proceed with your presentation. So please, sir.
Okay, thank you very much. Good afternoon to all. I hope all can see my videos and nicely hear my voice, right? Can you?
We are not able to see your video till now, sir.
Okay.
It is not visible to us.
Can you hear my voice?
Yes, it is clear.
Okay. So
you can share the slide.
Okay then.
In the share option, sir, you will get some options, entire screen. That option you have to follow.
Can you see my slides?
Not yet, sir.
Okay, wait. Yes.
Yes, sir.
Okay.
Yes, sir. Sir, better to go for slideshow, sir. Slideshow. Yes, now it is okay. Perfect.
Okay. Thank you for your assistance and in loading my presentation. First of all, I would like to thank the organizing committee of the e-conference to offering this opportunity to deliver an invited talk on my research experience. The title of my presentation is going to be on conducting polymer soft actuator or artificial muscles, synthesis, characterization, and fabrication. Let me explain my background. I am the senior lecturer in physics at the Department of Physical Sciences, Faculty of Applied Sciences, Southeastern University of Sri Lanka. So this is my university entrance, and this is the place, my university, which is located in the southeastern part of Sri Lanka, and this is the main entrance. And this is the brief overview of my university. This is the 10th National University in Sri Lanka. And we have 6 faculties and around 38 units. And we have 5,000 internal student population and 10,000 external student population and 300 postgraduate students. So I am attached to Faculty of Applied Sciences. So let me share some pictures of my faculty. This is my faculty entrance and the administration, and inside the faculty and some laboratories. So these are the departments I at our faculty, we have 5 departments. Department of Biological Science, where the botany and zoology are offered, and mathematical sciences, pure and applied and statistics are offered. And Department of Physical Sciences, where I am working, that offers physics and earth science, and Department of Chemical Sciences offers chemistry, and computer science offers the computer. Other than that, we have in our faculty, we have 5 unit and centers, postgraduate unit of Faculty of Applied Science. Currently, I am working as a director for the postgraduate unit. And the Science Research Center is dedicated for the research activities for a postgraduate and undergraduate students, and intensive industrial training unit, and internal quality assurance unit, and extracurricular activity monitoring center. So these are the background of this my faculty. And the degree program. So our faculty offers a 3-year general degree program and 4-year honor degree programs in biological sciences and physical sciences. And also our faculty offers postgraduate by research, MPhil and PhDs programs. These are the courses taught for undergraduate physics students. And these are the courses for honor degree students. In Sri Lanka, the honor degree in physics are offered in a limited students. It is assumed that it is equal to the master of by coursework. And these are the elective courses. And research facilities in my lab and in our physics. So we have a dedicated lab for research activities, advanced physics lab. This is the entrance. And in our lab, we have auto lab potential stat galvanostate working station, along with electrochemical impedance characterization and electroquartz crystal microbalance and the cyclic photometric, which are mostly used for polymer studies and artificial muscles application. And that PV analyzer for a solar cell studies, that is another part of my research, the spin coater and the sample preparation rooms. So we have separate rooms for separate instrument. So I would like to share our annual science research session poster. Annually, we are hosting a research session in November or December due to this pandemic situation. It is actually usually scheduled in August, but it was postponed to 30th of November. So the deadline is still open. The students or the undergraduate or the postgraduate students, even the academic, you can submit your article if the tracks are interested to you. With that, my background, I would like to make this presentation into 2 parts. One is the necessity of scientific research for sustainable development. The other one is my research experience and exposure in physics. So since this workshop is a motivation to the students for doing research, so I would like to make a small inspiring research and advantages by doing research. So I think scientific research is an important part. Without scientific research, nothing can be done. But I hope I don't need to make any much introduction, but I would like to share some quotes for inspiring the research activities for undergraduate students, especially. So no research without action, no action without research is one of the motto given by Kurt Lewin. He's a psychologist studying, he's famous for human behavior in environmental effect. an environmental factor. Then the Albert Einstein telling that the research should bring new knowledge. Then the Bill Gates, he highly believes innovation. The innovation should bring the real fact so that the development can be obtained with the research. Doing research is timely needed. So there are a lot of benefits of scientific research finding to the society. So I would like to highlight the discovery of COVID vaccine that is serve a lot of lives at this pandemic situation. So the scientific research is a key sustainable development of a country, so that a lot of countries invest an enormous amount of scientific research work happens all over the world, including in Asian Pacific countries. The research findings are measured quantitatively by the research articles or index journal research article and patents. So I would like to share some of the recent World Bank survey about research publication in science and engineering. The number of scientific and engineering articles published in the following field: physics, biology, chemistry, mathematics, clinical medicine, biomedical research, engineering and technology, and earth and space science are plotted. So you can nicely observe from 2000 to 2018, the publication by annual increased steeply and gradually. In 2018, 2.5 million standard research article has been published in ISI Index Journal. So on average, annually, 2.6 million research articles are published in science and engineering areas. So these are the countries leading in the world scientific publications. So this is for the inspiring, these are for inspiring the undergraduate students, especially. So China is leading in 2018, then the United States, and then India, then Germany, Japan, so on. Several countries believe that research brings the innovation brings the sustainable development. So massive investment in research and development activities are done in several countries. So these slides explain how much amount and invested in research and development activities. So the United States, the top. The second one is China. So when you look at here in this here, the gap between the China and the United States comes closer. So China is vastly improving in their research and development. So the demand for the standard researchers are high in the world because there are a lot of fundings are accumulated for research and development activities. So the annual demand for scientists or researchers in the world increases rapidly. Of course, the smart researchers are honored with higher salaries, more benefits and facilities and perks. So if you are a smart researcher, you can get a better job, good salary, fantastic facilities. So now I would like to share career prospect for scientific research. If you are willing to make your career as a scientific researcher, you have to focus on two key factors. Those are strong exposure in research, and strong proven track record in research. Strong exposure in research area or field, and strong proven track record in research. Proven track record means you have to have a periodic, a regular periodic publication of research article in good refereed journal having high impact factor. So your development in research field is assessed by proven track record. So I would like to share one of the recent advertisements posted by University of Surrey for research fellow in experimental nuclear physics. So you can see a proven track record of research contribution in experimental nuclear physics is highly expected. So when you are looking for a research career, your career prospect should have a proven track record of research supported by index journal publications. So when you are studying or involving a research degree, you have to have a better research track record. Not only that, career prospect for academic position or faculty, if you are willing to join as an academic position or faculty, these are the two factors are highly expect in order to show an evidence how the faculty position are highly expected the track record. So here you can see this is one of my co-worker, Edwin Jagger. He's not actually a co-worker. He is my partly a supervisor for my fellowships. So he, in his website, you can see my research. Under his research, he has put all the information, what are the research he is doing. So the research plays an important role if you are planning to have a scientist or a researcher or a faculty member. So no one can escape from the research if you are willing to have your career in a research-related fields. So I would like to show you an evidence how this track record in research is necessary. So this is the recent advertisement of University of Khalifa University for a position of academic position, assistant professor or associate professor in physics. So this is a screenshot I had just for your reference. So in the requirement, you can nicely read strong research potential demonstrated by relevant publication in high impact journal. So if you are going to compete with international market, then you have to have a strong research potential demonstrated by a track record having a high impact journal. In Sri Lanka, even in all over the world, the academic staff are considered as a counselors. The academic positions are based on 3 pillars: research, teaching, and service and administration. Among these, research is being a prime task comparing with other tools. So I would like to share a recent academic life map developed by Dr. Susan Waddell. She's an anthropologist working at New Zealand University. So she highlighted the necessity of the research in the academic career. You can see she's listed all the research related works, and service. Most of the service are related with the research for an academic life. So if you are planning to join as a faculty, you have to have an enthusiastic and regular development of research and services. So now I would like to share a snapshot of my research work, the background of my research activities. So my research activities is a development of conducting polymer actuator suitable use in soft actuator or artificial muscles. Actually, this research project is based on the developing a material for the soft actuator based on the conducting polymers. There are several prototyping devices has been developed. Even some companies are adapting our research outcomes for their device fabrications. I will come on later. So the main title that I am working on is the development of conducting polymer actuators. My research area or keywords are conducting polymers, ionic and soft actuator. So my project relates with the conducting polymers and ionics. It means the ionic motion in aqueous media can be explored using our model, and soft actuator, the design and development of soft actuator. So our area is an interdisciplinary, interact with 3 area of science. This is a collaborative material development research project involving 3 institutions. In my institution, Department of Physical Sciences, and me, and the University of Belonia, and Technical University of Denmark, Department of Chemistry, Technical University of Denmark. So in my institution, I am the co-worker, and Professor Karim at University of Belonia, and Stin Skaraf at Department of Chemistry, Technical University of Denmark. Those are the 3 works in this project. So now let's give a background of my research work. Base material is electroactive conducting polymers. I don't need to give much explanation or introduction about conducting polymers. It is discovered by 2000. Common example for polypyrrole, polyacetylene, and polyaniline. The significant chemical feature of conducting polymers is an alternative single and double carbon bond structure. Normally, the conducting polymers are insulated but become conducting when oxidized. So it is simple. When we apply a small voltage, around 5 voltage, we can make this conducting polymer as a conductor, like our conductor, because one of the double bond is non-delocalized, so that it will open up and close. So that when we apply an increasing voltage, the polymer backbone is oxidized, the electron is removed, the conduction occurs. When we apply a negative or decreasing voltage, again it is reduced. So it is switched in between conducting state and non-conducting state. Generally, the redox process is often done in presence of electrolyte. So the oxidation or reduction or the redox process is an electrochemical process, is done in presence of electrolyte. When a conducting polymer is redox or oxidized or reduced in presence of electrolyte or a salt solution, then the ion presence outside will move into the polymer as shown in the figure. Not only ion, anion, cation, even the solvent will move, so that the volume of the polymer will change. Right? Because of that, the physical properties of the polymer will change. The conductivity will change, color will change, stiffness will change, volume change, hydrophobicity also will change. So this is the basic origin and idea of the conducting polymer, which is used in several applications in research field. The change in mechanical properties due to change in oleum is exploited as artificial muscles. The change in mechanical properties during the oxidation or reduction process is exploited as artificial muscles. Our group successfully discovered a system based on conducting polymer polypyrrole doped with large dodecyl benzene sulfonate anion operating in aqueous electrolytes. So our group has successfully discovered and submitted and explored several physical properties and mechanical properties. Several articles has been submitted. Still, this system is still in device fabrication applications. So now let's move on the synthesis and characterization of polypyrrole DBS actuator. This is highly technical. So here the polymers can be prepared in a chain polymerization or the condensation polymerization. For a laboratory scale, for getting a uniform film, we are preparing the conducting polymer in galvanostatic electrochemical polymerization. We have a dedicated instrument for that. And the characterization of polypyrrole or polypyrrole actuator. So the normal characterization is done by cyclic photometry and electrochemical quartz crystal microbalance and force measurement instruments. So cyclic photometry is a basic to study the charge move in and out of the actuator, and the EcoCM gives the information about what are the species that can go in and come out and what happens inside the polymers. The EcoCM, what we are using, the accuracy of 0.9 nanogram. So it is the capacity of 1 nanogram. We can do the measurement up to the individual ions weight. And the force measurement instrument, that is measure the mechanical properties when the ion moves inside the polymer. Stress, strain, Young modulus can be observed or can be studied quantitatively. So this is the electrochemical synthesis. So for this purpose, we are using the AutoLab. This is a technical one. So I just move faster. And in our lab, we have a AutoLab working station that is dedicated for preparation of conducting polymer films. And for even the same setup, it's a working station, can be used for cyclic photometric and EcoCM setup. The schematic diagram of the EcoCM setup is based on the AutoLab. We are using the Govt electrode. So same setup can be used to reveal the ion information about moving species. And this is the schematic diagram of force displacement measurements. This instrument will explore the mechanical parameters of the system. It can be used in two modes, constant speed and constant force. We can measure the extension with constant force, whereas we can use a constant speed and we can measure the force. This is the real experimental setup. So a small electrochemical setup, counter electrode, working electrode, and a reference electrode. So these measurements are in situ measurements. That is it is a cyclic photometric in situ measurement. Other than that, we have a optical setup that is not related with my presentation, so that I left out. UV visible absorption with in situ cyclic electrochemical measurements. The sample results this is the synthesis of PPY DBS soft actuator. We are using a constant current to fuse the pyrrole monomer to make the film by doping with dodecyl benzene 9 terms. So here the voltage explains the films are prepared uniformly. Then the EQCM characteristic studies, it reveals the ion species moves in, and aqueous or the solvent moves inside the film. And the mechanical characteristic, stress, tensile strength, and speed can be measured. So, and the speed and frequency, the speed and frequency can be measured with a different scan rate. So when the speed move faster, then the actuation or the extension of the film varies. This result is obtained for 0.1 molar sodium chloride solutions. So there are several companies and engineers are working on this material PPY DBS actuator. So our part is to develop the material for various specific application, using as a artificial muscles for specific applications like artificial muscles or textiles actuator or soft robotics. So one of our co-worker, Edwin Jagger, is mainly focusing on his fabrication part. We have closely working with him, and some of the prototyping devices is acquired by Krigana Medical. They are developing some actuators for real applications. So I would like to make some remarks for the audience. The outcome of research yield innovation, new piece of knowledge and idea. So the demand for researchers having proven track record is very high. Multidisciplinary research with collaborative background is highly appreciated and recognized. So thank you for your patient listening.
Thank you, sir.
Yeah.
You can, sir, stop the sharing. Then we will have interaction
Okay.
with the participants.
Okay, good.
Hello. So thank you for such a nice deliberation. Now we have few queries asked by the participants. Am I audible? Hello?
Yes. Yeah, I can audible.
Okay, sir. Okay, sir. So there are few questions like it is asked by Anamika Dev. Sir, how do we characterize nanoparticles?
It's a general question.
Yes,
There
yes.
are, yes, it is not related with my
Topic,
presentation,
I
but
know.
anyhow, yes.
Yes.
But anyhow, there are a lot of characterization techniques, SEM, TEM, it depends on. So there are vast areas of instrument collections.
Yes. Thank you, sir. One more question asked by Dr. Sujit Ranjan Das, sir. How does polyaniline become conductive?
Yeah. So the polyaniline, it has unlocalized bond. When we supply a small voltage, that delocalized bond will open up and makes the conductions, so that it is conductive. That is the basic mechanism. All the electroactive polymer is same.
Okay, okay, okay. So thank you, sir. And uh, the other questions I may send you in your mail so that you
Okay,
can give the replies of the participants. So thank you, sir. Thank you
okay,
for such a nice deliberation, and I appreciate your lecture, which was very useful to the viewers and me too. It was a remarkable presentation, sir, with full of information. We
okay,
thoroughly enjoyed and learnt a lot through your deliberation. So thank you once again for accepting our request, sir. Thank you.
okay. Thank you for your opportunities and thank you for all. Thank you very much.
Thank you, sir.
Thank
Thank you, sir. Now, before asking Dr. Subroto Dev, sir, I would like to summarize the lectures which is given by the different resource persons throughout this technical session one. The first one, given by uh, which is given by our madam uh, Munira Janatul Kobra madam on the topic known as nuclear physics introduction to an intranuclear cascade model for nuclear reaction. So it was a nice experience to hear. She has clarified few things and focuses on certain factors. She has started her lecture uh, with the brief profile given by her regarding their institution, students, and infrastructure and overall institution. After that, she explained about the nuclear physics, the core of matters of fuel of the stars, and very elaborately explained about the carbon-free energy. She explained the application of nuclear physics by explaining preserve how to preserve the food without hampering the food values or qualities. She explained she focuses on nuclear medicine too, power from fissions also. The basics of nuclear physics, she started with brief history of nuclear physics. She explained the atom through explaining the nucleus and nuclear properties, and also explaining that the charges density inside the nucleus is constant. Nuclear binding energy, that the total mass of the nucleus is less than its constituents. She also highlighted about the radioactive decay, which is a spontaneous emission of radiation. She explained how cascade model is a time-dependent INC model. She presented the concept of ADS, that is accelerator driven system, to optimize different parameters of ADS transport code are used. She also at last explained about the heavy ion cancer therapy. So it was the overall presentation of Madam. Then the next presentation, which was given by our Dr. Nirmal Kumar Sarkar sir. His topic was algebraic model in vibrational spectroscopy, a probable epicenter of spectroscopy research in the next part of 21st century. He highlighted many things, but there are few points which I must mention, that he focuses how education changed due to the present COVID situation. What are the new challenges we are facing in higher education? He focused or said that the advancement in physics during pandemic era. He presented the ranking of different universities in India by Education Ministry of Education. He explained about the scope of research in physics in India and abroad also. Then experiment experiment research in India is lacking behind. Why? He has given the reason as compared to the foreign universities. Education funding is to be raised in India. He has explained the plus points of research in theoretical physics. He rightly explained the propagation of electromagnetic radiation. He also focuses on gradual development of algebraic model. Then he elaboratively explained the alternative approach to study molecular spectra is being explained. Local mode Hamiltonian for linear trigonometric molecules. Then he explained the relationship between algebraic and vibrational quantum numbers. So this was the overall summary of the presentation given by Dr. Nirmal Kumar sir. Then the last lecture was given by Dr. M.J.M. Jaffin. He explained the conducting polymer soft actuators or artificial muscles synthesis, characterization and fabrication. He displayed the world in the scientific publications. Before that, he has started with brief introduction of their working place. Highlighted the discovery of vaccines also. He explained the necessity of scientific research for sustainable development. He shows the demand and status of smart scientific researchers as a means they get good salary as a profession also to get strong exposure in the research and strong proven track record in research. He mentioned about his research work on development of conducting polymer actuator suitable use in soft actuator or artificial muscles. He focuses on synthesis and characterization of PPY actuator, magnetic synthesis PPY actuator also, electrochemical. He also focuses on device fabrication based on PP actuator. So this is all about the summarization of all the lectures given by the resource person, which was a wonderful experience for every one of us, especially for me also, so that I got the opportunity to chair the session and learned a lot through these presentations. Now, without any delay, I would like to call upon Dr. Subroto Dev sir, Assistant Professor, Department of Physics, Women's College, Agartala, for the report presentation, which will be followed by a vote of thanks. So please, sir.
Okay, so a very good afternoon to each and everyone present in this international e-conference on advancement of research in physics and teaching techniques during this pandemic period. That is ARP-TTPP 2021, being organized by the Department of Physics, Government Degree College, Dharmanagar, in collaboration with Department of Physics Women's College, Department of Physics ICVC College, and Department of Physics RK Mahavidyalaya. First, I would like to express my sincere thanks and gratitude to the organizing secretary, Dr. Raghunandan Das, Assistant Professor, Department of Physics, DTC Dharmanagar, for organizing so nicely such a beautiful scientific platform during this tough time to create awareness and to motivate the young students, researchers of this region. I'm also thankful to the organizers for allowing me to deliver the summative report along with the vote of thanks in relation to the first technical session of these 2 days international e-conference. Now, before going into the brief report, let me first share my views about the motivation behind such program. Like the last academic year, in this present academic year also, students and teachers are almost confined to their home because of the pandemic caused due to the outspread of COVID-19. And teaching learning activities are almost in pause. Although online classes are going on at this moment of time, but still, as we have some time, apart from our routine online classes, to organize this kind of seminar, popular lecture, conference to motivate our student community and also to aware them about the recent advancement of physics research and also about the enormous changes that occurred since last year in the teaching techniques too. Now, in this first technical session, we are having with us Dr. Monira Jannatul Kobra, Associate Professor, Department of Physics, University of Rajshahi, Bangladesh. Dr. Nirmal Kumar Sarkar, Associate Professor, Department of Physics, Karimganj College, Assam. And Dr. M.J.M. Jaffin, Senior Lecturer, Department of Physics, Southeastern University, Sri Lanka. On behalf of organizing committee, I am expressing my sincere thanks and gratitude to all these three learned speakers. The whole session is chaired by Dr. Ankan Sinha, Secretary Teachers Council, Government Degree College, Dharmanagar. I am also thankful to him. In the first lecture, Dr. M.J. Kobra delivered a beautiful presentation on nuclear physics, introduction to an intra-nuclear cascade model for nuclear reaction. She explained deliberately the basics of nuclear physics, including various nuclear models, the idea of nuclear forces, binding energy per nucleon and its importance, radioactive decay, which are extensively studied by our UG and PG level students, the importance and applications of nuclear physics, role of the said physics in different aspects, nuclear reaction, use of nuclear radiation in a constructive manner, such as nuclear medicines, nuclear powers, the role of nuclear power plants from which we are getting sustainable energy through nuclear fission or nuclear fusion processing in near future are beautifully explained by her. And the importance of shifting the nuclear reaction from low energy range to the intermediate or high energy range is also highlighted. The basic principle of INC model along with its numerous application perspective are also discussed by her. Now, in the second lecture, Dr. Nirmal Kumar Sarkar gave a presentation on the topic algebraic models in vibrational spectroscopy, a probable epicenter of spectroscopy research in the next part of 21st century. He first discussed the scope and prospects of research in experimental and theoretical physics, highlighting the importance of having more researchers for a developed nation. He beautifully explained the role of spectroscopy, especially algebraic models in vibrational spectroscopy research such as Lie algebra, and the importance of use of various algebraic models in various vibrational structures has also been illustrated beautifully by him without going into much more calculations. The promising possibilities of explaining various experimental results using a number of algebraic models has also been highlighted by him. Dr. M.J.M. Jaffin of Sri Lanka gave the final lecture of this first technical session on the topic conducting polymer soft actuator or artificial muscles, synthesis, characterization, and fabrication. In the first part of his lecture, he demonstrated beautifully the necessity of research for sustainable development through some famous quotes and thereby motivates the young generation, mainly the undergraduate students. The extent of investment in R&D activities by a nation plays a vital role for the development of that nation in the long run. He also emphasized on that. The possibility of building a career in research field can be attained by maintaining the continuity and proven track record in the form of publications in high-impact journals or patent generation or both. In the second part of his lecture, he discussed the main research area actually been carried out by him, and he discussed about the generation of conducting polymers actuator, its design and development, significance of conducting polymers and their characteristics, switching of conducting and non-conducting state of conducting polymers under certain conditions. He also explained that the variation of the properties of conducting polymers is mainly the key features which are used in several applications. We discussed in detail about the preparation, characterization of these conducting polymers or conducting polymer film by a number of processes which are available in his lab. I am again thanking all the learned speakers of this technical session. Before conclusion, I want to just convey my thanks also to the participants for whom this program is designed. However, a matter of deep concern is that the number of live participants is not at satisfactory level in comparison to the number of registered participants, which is around 500 or so. So I would like to request humbly to all my dear registered participants to join all the lectures. I strongly believe that if you listen all the speakers seriously, you will definitely know various aspects of research and current developments of this subject, which is extremely important for shaping your future. My sincere thanks also goes to the technical team, especially the technical coordinator, Srimati Mitu Dash, Assistant Professor, Department of Information Technology, Government Degree College, Dharmanagar, for working hard to run these sessions successfully. At the end, I just want to share a famous quote of Sir Benjamin Franklin that says, "Tell me, I forget. Teach me, and I remember. Involve me, and I learn." This is the third one, that is, involve me and I learn. We are all trying to do so. Thank you all for your kind support throughout. Have a good day, stay home, and stay safe. Thank you.
Thank you. Thank you, Dr. Ankam sir, Assistant Professor, Degree College, Dharmanagar, and chairperson of the session for chairing the session and very beautifully you run the session. So actually, and I am also expressing my thanks and gratitude to Dr. Subrato Dayar, Assistant Professor, Department of Physics, Women's College, Agartala, for presenting a very beautiful report. Very nicely, he has pointed out all the points what has been explained in the lecture. So I am also expressing my thanks and gratitude to Dr. Subrato Dev sir and Dr. Ankon sir for presenting the report, for highlighting the report, and for running the session so beautifully. So thanks all. So Ankon sir, we may conclude today's session here itself.
Okay, okay, sir. So we are ending the session over here. We will meet again
So,
tomorrow.
so there is one announcement. So the feedback link will be there for 30 minutes. It will remain active for 30 minutes. So all the participants are requested to fill up the feedback link, and it is necessary for having the e-certificate. So I am requesting all the participants to go through the feedback link and you fill up it and submit it within 30 minutes from the time it has come into activation. Okay. So thank you all for being with us.
Sir,
Thank you
actually,
all.
few are asking for the feedback form again. Someone are
They are
asking for
asking.
few asking for feedback link to give again in this platform, so that they can have.
Whether it is working or not, it is working that we have seen.
Yes,
So
yes.
once again, I am highlighting the feedback form, the
Okay,
link
sir.
for the feedback form. Uh,
So,
okay,
so
that
we
I
are
am giving.
okay. So we are sending the ending the session over here. Okay.
Yeah, we are ending the session. So just a minute, you please keep. So once again, that I am giving the feedback link. So all are requested to go through this feedback link. Go through. This is the feedback link for the first technical session, and it will remain active for 30 minutes. Automatically after 30 minutes, it will be deactivated. So within the 30 minutes, please you fill up, because for having the e-certificate, it is necessary to fill up all the feedback. So, okay, thank you once again. Thank you all. Angan sir, we may end now.
Okay, sir.
Thank you. Thank you, Rahul sir. Thank you all. Thank you all the participants for being with us, for your active participation.
Okay.
Thank you. Have a good day and